data structure and algorithm. Let's go ahead. What is data structure and algorithm? So, can any one of you want to tell what is data structure and algorithm?
Storing data in tables in a form.
Okay. What is the benefit of data structure and algorithm itself?
Storing data in tables, sorting them, bubble sort,
Right.
heap sort.
So, first we'll understand what is data structure. So, data structure is method of organizing the data, right? And matlab, means wherever we are putting the data in an array or in a what to say different form, tabular format or some other format. So we use data structure to sequence those data or put that data in a list. So there are data structure like array, linked list, stack, queue, sets, map, hash tables, or search trees, right? So what are algorithms? So algorithms are uh, a sequence of steps executed by computer that helps you to take input and transform into a target output. So algorithm is set of rules that help you to process that data. So if you look at the previous slide, algorithm what do? So it's a set of rules that help you to process the data and provide you the given output. And the you know in algorithms there are search algorithms, there are sort algorithms, there are tree traversal or graph traversing, uh, dynamic programming or hashing. uh, Data structure and algorithm is helpful to create. It's not language dependent. If you try to understand, data and structure and algorithms helps you and helps everyone whoever understand data structure and algorithm to uh, build logic, develop how to create a program from problem statement to output. And most important thing, in today's world, wherever we look at social media marketing or different applications, we always look into what to say, what algorithm they are using. If we look at the different time frame, so TikTok was became popular in which year? 2019 or 2020? Can somebody tell me? Right. So 2019. Why TikTok gone, get popularity? So there was different applications also. They tried to copy TikTok, or lot of people tried to copy Facebook algorithms. Lot of people tried to copy YouTube algorithms, but they were not able to do it, right? So algorithms are that help you to process the data points that you are reading on a dynamic front. Means a person who is uh, going through reels, shorts, or maybe TikTok, right? So if you are looking at a video for 2 seconds more, right, slowly gradually it will provide you relevant data only. They'll create a bubble. If you understand social media, so if you are looking at a particular kind of video, slowly gradually you are going to see more videos related to that only. The same way in Amazon also, or even a lot of people talk about that ki even if people talk about on phone ki I am thinking to buy a shoes, right? So they'll start seeing the advertisement related to shoes only, different brands, Amazon or maybe Google, right? So Google and Amazon is tracking data, right? So they know what people trying to buy, what people don't trying to buy, right? So on the basis of those data points, they'll try to predict, right? That machine learning part came later, that okay, algorithm invested into machine learning will create a more optimized way, right? So data structure and algorithm, if you learn from a basic level, it help you to optimize a program. I am giving a same program to 10 programmer. Someone will do in 100 code, 100 line of code, someone will do in 50 line of code, someone will do it 40 line of code, someone will do it 60 line of code. So every line of code will increase the time that algorithm is taking. So creating a more optimized and efficient way of code, we need algorithms, right? So algorithms also help for, if you will try to understand, there are two terms with algorithm. One is time, second is space. How many memory they are going to take and how much time they are going to take, right? On the basis of that we choose the most efficient algorithm for a given problem or given program, right? Right. So Hindi and English specifically, I'll try to differentiate. Maybe the last time we have done 30-minute Hindi and 30-minute English, if you remember. So from tomorrow we will do Hindi and English separately, right? So we will try to form an alternate days, right? So on maybe Sunday, Tuesday, and Thursday there will be English. On Monday, on Wednesday, and Friday there will be Hindi. So I'll start teaching 1 hour alternate day, so that you can whatever you will try to learn today, you can implement it tomorrow, and we will discuss it day after tomorrow, right? So we will try to go in an alternate day format, so that you can also get the time to create different things according to you. Give me 1 second. Hello, Harvinder. हाँ हाँ, ठीक है. Right. So yeah, Hindi classes and English classes will be divided as an alternate day, so that everybody will get their 1 hour time properly, so that they can ask questions, they can understand how to create programs through algorithms also, right? So these are the data structure and algorithm, and that is why every programmer who is thinking to build career into programming, they learn data structure and algorithm, so that they can understand how to build logic or how to create a pure program, right? So if you are trying to create a grocery application or some ad tech application or some website, slowly gradually you will understand ki on the basis of your data structure and algorithms, whatever algorithm you design, क्योंकि how data should flow, it will optimize your program and your output also. So today we'll try to focus more on search algorithms. Okay, what are the basic search algorithms, so that we can go ahead and understand few search algorithms into it. So what is a search algorithm? So searching is a fundamental operation in computer science and plays a crucial role in problem solving across domain. It involves finding a specific element within a collection of data such as array, list, tree, graph, or database. So the primary goal of searching is to determine whether the target is exist in data or not, and if it is exist, identify the location, right? So let me explain you with an example. What is search do? So for understanding, basic principle of searching, first understand array. I know what is array. Array is collection of similar data type. So what array do? So if you look at, I need to store 5 numbers, right? 10, 20, 30, 40, 50. Initially I need to take 5 variables, right? So like there is a variable, to B variable, C variable, D variable, and E variable. 5 integer type variable I need to take, right? So that they all 5 numbers can be stored. Now in array, what we do, we have again store in a single variable, right? We will say ki, okay, it's an integer a, the array of 5 element, right? And give those element an indexing. So first number will be stored into 0th position, second will be first position, second, third, and fourth. Means whatever the total number is, array sizes will be n minus 1, right? So the total size is 5 and the highest index is 4 over here, right? Because we start from the 0. Okay, is it clear now or is it still inconsistent?
It is clear, sir.
Okay, okay, Raja, thank you. So this is the basic structure of an array, right? So array is one of the basic data structure that we use. So in an array of 5 element, if you look at this array, we can say ki, okay, this array is first of all sorted. This is from 10 to 50. The sorted, the ascending order is sorted. But now what search do? I need to search ki 25 exist in this series of element or not. So we will start searching this number into this list. If that is not there, it will return us what कि okay not find or not available, right? Or if that number exists, like if you are trying to find 40, so it should return me the index number कि okay the 40 is on the index number 3. So that should be the purpose of searching algorithms कि okay whatever number or whatever even character also, if it is a character type array or if it is a string type array, so we can search those numbers directly, right? मतलब string or character or numbers. Okay, so what is the use of DSA in day to day life? Uh, Day to day life, if I'll tell you, right? So there is two way that you need to understand. Uh, you need to go from A point to B point, right? So if I'll try to explain you in a pure layman language, ki normally what is the use of algorithms data structure? So from A point to B point, there are three probable ways that is there, right? So let me explain you probable ways. And any point of time you need to reiterate, please, you can send me a message or wait for 5-10 minutes so that I can see the message. Cause normally when I'm teaching, normally I'm focused on to more about telling, right? So I'm not looking at the messages. So from A point, or even you want to imagine in a different scenario, it is your home, right? Or it can be your college, or it can be your office, or any place where you want to go, right? So from one way is like, if different way, I'll try to explain you. One is way is bus, right? You can take a bus, and bus will take you around 50 minutes of time, right? And it will take around 10 rupees of your resources, and you will reach over there, right? Second is, if I'll say bike, so it will take around 30 minutes of your time, or 50 rupees of your petrol, and you will reach over there. Then you can take a car, right? It will take around similar time, 25 minute or maybe 30 minute, or it will take you around 300 200 rupees of your time, your resources, and then you will reach over there. First, this is how you make decisions on the basis of algorithms. So on the basis of first, according to your time and resource, you choose a decision, right? How much money you have and how much time you can invest. You are looking at, okay, I have 30 rupees or I have 40 rupees. I can't go into bike, I can't go into car, so this is the only option that I am going with, right? But I have those resources. Then it is more about what to say. If you have the money, you have the resource of car, then you can use that also. Now, if you are going to choose, right, bike, car, or this is the first decision that you will take. If you have all those resources, right, what is the second thing you will take about this? Now, uh, you are saying कि okay, I'll take the car or bike or anything else, whatever you want to take according to your convenience, or traffic also, right? So a lot of people think कि okay, we'll take the car if I have it. No, if you are into Mumbai, if you are in Delhi or Bangalore, you don't want to take a car because you will stuck in traffic, right? So now there are three ways to go, right? Three ways in a sense. Uh, there is a one way that will go from the old city, in a sense that when you go out from your house, you will take a left, you will go into from old city road, and there is high traffic, and it will take around again 50 minute, or it is around, in terms of kilometer, it is like 6 kilometer only, and you will burn around, what to say, 100 rupees of petrol, right? So there is a one way, right? There is a maybe another way that maybe what to say, less traffic, but it will take you around what to say, again same 50 minute, and this route will be around 10 kilometer, or there will be 100 150 rupees of, what to say, uh, amount or petrol burnt into it. And there is a third way, right? Zero traffic, it will take you around 40 minutes, but it will be around 18 kilometers maybe, right? And it will burn around 250 rupees of petrol and anything else, right? So which way you want to go with? That's what data structure and algorithms all about, right? So in a same way, when you make a program, you make an application, you decide what to do. That how you analyze the whole situation. कि, okay, how much time I'm investing? There are two major criteria that we look at: time and space, right? So on the basis of time and space, because time is also money and space is also money, right? So if you are using 1 TB of memory, or you are starting using 2 TB of memory, it will increase the load on server, load on your what to say, you need more space over cloud, right? So on the basis of time and space, you choose a best efficient way for your situation, right? The way Google server works, or maybe Amazon server works, a normal server will not work according to that, right? So they have the time and space both, but everyone don't. So that's the use of data structure and algorithm every day. So same way, like if you open a Google map, it is the similar situation, it use data structure and algorithms. So on the basis of wherever you put the destination, on the basis of your destination, basic kilometer, the traffic part, you see red part over there also. If there is a traffic jam, on the basis of two three things, it will decide your path, right? The same way, if you choose a car or a motorbike, or even what to say, walking, it will choose you a different path. So they understand कि okay, on the basis of what mode you want to drive, or what way you want to take, it will give you the best efficient way to reach your destination. That's what data structure and algorithm all about. Is it clear, or do I need to explain this example again?
How
Yeah, go
how
ahead.
do we find the most efficient way?
You can't, you have to choose, you know so like if you look at over here, so if I see कि okay, my priority is time, right? So I'll choose this way कि okay, money doesn't matter, kilometer doesn't matter, time is matter. For me, time is the only priority, right? Then I'll choose this one. But for me, if time doesn't matter a lot, it is okay to have 5 minutes or 10 minutes here and there. But money matters. I can't invest 250 rupees. So over here it maybe seems 250 rupees or 100 rupees, but if you look into lakhs or crores, it's like 200 2.5 times, right? It's 100 and it's 250% of that 100, right? So it will be a huge difference over there. So when you decide कि okay, money is important, so you will choose the most efficient is for you is this one, right? So again, the same way, how what's the most efficient way to start your career, right? Go to Harvard's, go to Stanford, or go to some IIT IIMs, right? But everybody can't go over there. Few people, maybe they are talented enough, but they don't have money to go. So people who have those resources, they can choose. People who don't have, they can choose from their own situation कि okay, what I need to do. So that's the efficient for me. For me, what is efficient for me maybe not efficient for Shiven, right? What is efficient for Shiven, maybe it's not efficient for Raja, right? So everyone, or every company, or every application has a different efficiency level. Is it clear?
So priority upon the priority depends the efficiency.
Right. So again, if this is the situation where we have to take bus, bike, and car, right? First, is that resource available? First question is that. If it is available, then what to do, right? This is the second question. So if you are like anyone is planning to what to say, start an application of, like what to say, Instagram like application or TikTok like application, right, or YouTube like application. First, can you start it? Can you invest 5 to 10 lakh rupees minimum to just start an application? First step, if it is there, you can start. Second, it will depend on how much user base you have, how much streaming you are there doing. So if you there is 5000 customer base in your application, you have to pay 5 to 10 lakh rupees bill to every day. Every month you have to pay AWS, Amazon Web Server bill to your what to say, just to keep running your application or keep streaming, right? So if there is a 50,000 users, so you need a different level of efficiency. So efficiency depends on your resources also. So if you have what to say 100 crore rupees in your pocket, you can do whatever you want to do as an application. But you have only 50 lakh rupees, so you can't be same efficient what 100 crore of resources provide you, right? Yeah, मतलब अभी तो it is also again. So if it is in shared resource, you are looking at कि okay, in a car we can travel 4 people, in bus we can travel 50 60 people. So that मतलब the public transport efficiency is completely different, right? So as normally you look at first what is efficient for you. If it is efficient for you, you will take it, right? So people मतलब when I was doing my BCA, I used to travel through bus, right? That was the only efficiency level that I used to get, right? Otherwise, मतलब if I used to say कि, to my parents कि okay provide me a car, then I'll go to college. They'll tell me okay don't go to college. There's no requirement to go to the college, right? So it is depends on resources. How much resource you have, how much money you can spend for those resources, right? So even somebody is saying कि okay the traffic is higher, I'll take an helicopter for that, they can also take it, right? So it depends on resources. So yeah, that's what search is all about. Searching the best. So again we come back into that part. So if you look at this array, we need to search a number into that array. So what are the possible algorithms that is there to search that? So there are two basic algorithms that is used by everyone, right? Uh, so choose the appropriate searching technique on the solving problem on the way data structure, data size, data order. Again, we will differentiate this okay, what is efficient from this part. So first, there are two basic algorithms. One is linear search, one is binary search. Uh, when we will complete both, we will try to understand okay, which one was efficient, right? So linear search, also known as sequential search or a simple algorithm, right? Sequentially check each element in data until a match is found or entire structure has been searched. It is applicable to both sorted and unsorted data, right? So what it is saying कि we can search any number through sequential search or linear search. What linear search do? It will compare each data with each subsequent indexes. क्योंकि first I'll check is 40 is equal to a 0. So if I can tell this the number, I'll this is the number variable. So if number is equal to a00, right? If it is true, it will return 0th position. So now if we'll try to understand this, okay, on number it is 40 or a0 it is 10. What it will do, it will say okay, number not found. If number not found and there is more spaces into array, what it will do plus plus, means it will increase the counter with 1. Now we will check number is equal to a1, right? Then we will check number is equal to a2, right? The same way we will go ahead 3 and 4. So this is how we are going to search it. So this is our search algorithm basic. So if it is returning number not found, it will do increment. if it is not found, it will do increment. If it is not found, it will do increment. It will not found, it will do increment. Right? But if this number found, it will say yes, this number is found on third position, so we will return the index number. Now we will try to say we are searching 25, right? So first it will check क्योंकि number is found on 0th position, no, it will do plus plus. Then it will check with the next index. It will say not found. Then it will say not found. Then it will say again not found and not found. When the number is not found in the last index, it will return as not available in the list, right? So that's how it works, the basic linear search. So linear search is applicable for both sorted data, means this is a sorted data, and unsorted data also. So if it is 100 or it is 20, it is 355, it is 4 only. So this is the unsorted data. You can't predict ki next is bigger or smaller, right? So linear search is applicable on both sorted data or unsorted data, right? So now if I try to make a program with it, yeah, it will be a time taking algorithm. So I'll again try you another algorithm also, then we'll try to make a program for both. So we'll explain again. If you are trying to find 20, so you can go from every index number, and when the 20 is found, you will return 6. So linear search is very simple algorithm. It will go from, like, if you are searching 40, so it will checking with each and every index number, and when you will find it, it will return you the number, right? So second is binary search. So binary search operates on a principle of divide and conquer. So what it will do, it is saying कि okay, we work on a principle called divide and conquer. So it is given a sorted array. The algorithm compare the target element with the middle element. If the target is equal to the middle element, your search is successful, and the algorithm returns the index of the target. If the target is less than the middle, it will focus on the first half of the array. If it is bigger, it will focus on the second half of the array. So if you look at this example, where what they are saying, okay, this is the sorted list, means all number are sorted into an ascending order, 5 to 29, right? So if we are going to check what it will do, okay, search 24. So what they are doing, first they divide it in between, right? So this is the first, this is the last. We'll do the total and divide by 2. So this is the middle number. So 12 is there. If 12 is equal to 24, we have found our number. If didn't found, divide this from this part. So 12 will be the last part from 0 to this, and the next will be this to last part, means mid plus 1 is this, and now 24 is bigger than 12. We know कि it will always be available into the second part over here, means in a sorted algorithm, sorted array list, 12 is there, 24 we need to search, means 24 will always come after the 12. Now it will reduce their focus from this part, no need to search over here, and then focus everything over here. So again it will divide from,
Sir, why 19 is given as middle element?
pardon,
Sir, why 19 is given as middle element? Why not 20?
where is the 19?
Third step, sir.
Okay, over here you are asking.
Yes.
Okay, so over here first part is 6 and the last is 11, right? So 6 and 11 is 17, and 17 divided by 2 is, Abhi, who asked the question? 17 divided by 2 is, what is the answer? 8.5, right? So 8, matlab, if you focus on programming, integer will always go into 8. It is not float, it is not double, right? Index number will always into integer format, right? So 8 will be the middle number. Got it? Yeah. So because of that, we will now check with the 19 कि okay, 24 is smaller than 19 or bigger than 19. It is bigger than 19. So again, our first is this plus this. So 20 will be the first, 29 will be the last, and 25 will be the middle one now, right? It will check again, then again it will divide it onto this number only. After this number, they'll tell you कि okay, the number is not present in the array. I'll explain you with the example, with the same example. If we'll 5 to 29. So now we'll focus on 5, 10, 15, 20, 25, 30, 35, 40, 45. So now it is 9 and 50 is the 10, and we'll do the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is the index number for this array. Now first of all, always remember the basic binary search will always apply to the sorted list or sorted array. Why? Because it will focus on divide and conquer. If in a similar situation unsorted array is there, it can't predict ki next is bigger or smaller, or which is the bigger element over here. If 100 is there, it can't predict ki okay, next number is smaller than 100 or bigger than 100, right? So in this list we can focus on that ki okay, if 35 is there, means before 35 all is smaller, and after 35 is all is bigger, right? Or equal at least. It can't be suddenly over here there will be a 4. In a sorted list it will not work like that. So if sorted list is there, so it will always into ascending or descending model, right? So now if we'll try to do this, so first, yeah, again, right? So if you are getting it unsorted list, you want to sort it through binary, so you have to sort it first. So a lot of, if you look into a directories, right, so they focus to whenever they're storing the data, they'll make sure it is starting point is sorted. So on the basis of their sorting, they decide, right? So now if we'll take it okay, 0 is the first position, this is the first, right? This is the first, this is the last. So 9 plus 0 divided by 2 is 5, sorry, 4.5, 4. So middle will be 25. Now what number we are searching? If we are saying ki okay, we are searching 45, right? So if we are trying to search 45, it will check ki okay, middle is equal to number. It will say no. Then it will check okay, the middle is greater than number. It will say no. Then middle is lower than number. It will say yes, right? So it will check 3 conditions over here. If middle is smaller than number, means the new first will be is equal to m plus 1. Whatever is middle is there, plus 1 is the new first. So for our new first is 5 and last is 9 again. So now we'll do the total is 14. 7 will be the new mid, because we have discarded the previous list. Why? Because we know कि 45 is bigger than 25, so it will not going to find into this area, so it will going to find into this area only. So now middle again, so 40 and what to say, middle part is there. Now it will again check the 3 conditions कि middle is equal to number, no. Middle is greater than number, no. Middle is smaller than number, true. Then what we will do, first is equal to m plus 1. So this is the new first, this is the new last, right? So 8 plus 9, how much will be there? 17, right? So 17 divided by 2 is 8.5, again 8. So middle will be, again in this situation there is no middle, there is first, last, and middle will be the same as first, right? So it will check middle is equal to number, true, and it will return 45 is available at 8th position, right? So that's how a binary search works. So how much time we need to traverse it to reach to the conclusion? If 45 is at 8th position, right? So how much breakup we have done? First checkup, then second, then third. So we have took 3 to 4 step to reach at conclusion ki okay, then the number is found at the 8th position. 3 to 4 time only. Why? Because it divide and conquer, right? Where the linear search, if we are going to do it linear search onto a sorted list, what it will do, it will take 8 step to reach the conclusion, right? Okay, this number is found on the 8th part. So again, linear search will take a longer route to reach, binary search will take smaller route. But the, basic dependency is it can work into unsorted list, right? And this will only work onto sorted list only. So that was the major drawback with the binary search, ki you can't put binary search onto an unsorted list. So we need a sorted list to use binary list searching. Or linear search is, you can search into anywhere, right? It will take a longer route, but it will make sure ki every index is checked before saying you no, right? So that's what binary search. And there are few difference between those two. Binary search is complex as compared to linear search when you will make the program, right? So this example is showing you ki how much time will, sequential search will take. It is checking the same thing where, binary search just divided, then again first divided, the second divided, and in third divided, then it will found the number, and again it is searching till reaching the 11th part. So it is taking 11 steps and it is taking 3 steps. So as a stepwise you look at it, it is the time space complexity. We'll explain you later about that, right? So uh, the binary search is considered to be more efficient method that could be used with large list, right? So binary search is focused onto a major list where the data set is, humongous. Linear search is slow, right? Because it goes into sequential form. But again, number of comparisons are less into binary, number of searches are more into, what to say, linear search works with array, not with the linked list, or works with the array and linked list both. So now the question was, if the data is unsorted we can use linear search, and if data is sorted we could use binary search. Totally agree. And O की power n is time and space complexities in the algorithms, क्योंकि how much time and space they are taking, and on the basis of that we'll choose the algorithm. So we'll explain, if you are doing Btech, BCA or MCA, this will be your 5 to 10 number question part into your examinations. क्योंकि what is time space complexity of ON, O log n or ON square, different. So these are the two algorithms. Now we'll try to execute one of them so that you can understand कि, okay, how it works. So now if what to say, linear search one, so we'll try to do the example, and till that time you all can fill the attendance and feedback basically for these demo classes, so that we will also improve into it. So keep looking at the part. If you know Java, or you can practice it into Python also, or C++ also, whatever language you want to use, there is no need to use Java. But yeah, my primary language is Java, that is why I use it. So again, over here we'll create int a new int 10. So now I am going to store, what to say, a number part. Okay, we will get those data from the user only, We'll insert myself only. So let's insert int I is equal to 1, I till the time less than 11, less than is equal to 10, I plus plus. So we will store this number into a I plus 10. So there is some number is going to stored from 11 to 110 maybe. So not 11 to 20 only. Now we are going to search a number. Okay, if int number is there, that is we need to search in that array. What we are going to do, so we can even if you know core Java part, you can take these things from the user. Okay, take input from the user, then try to give output to the user ki number is found or not. Over here again, for loop we need to run. So over here we need to run two int I is equal to 0 till the time I is less than 10, I plus plus. So this is for the first sequence. If number is equal to AI, so we'll declare it over here so that it will be easy for us, is equal to 0. So if we'll find it, it will return break. So if we'll put over here one condition, if I is equal to 10, it means number not found, means we have traversed the whole list but number was not available into the list. Number not found. This is the basic example. We can do a better example with that also. Over here we can say, let's say we are found it, or we can share the location also, plus I think it will work. What do you say? Normally whenever I'll make a program, normally I'll always think okay, it will work or not. Now we'll look at over here. See, let's start with Java 7 or maybe DSA 10. DSA 17. Linear search 1 dot Java. Now we'll try to execute this program. Two while loop. One is to initialize the value. We are entering the value. I will show you also. So we need to print out that also what we are. Now we are taking one more loop also, because you have asked it why we took it. So now we'll take it like this: system dot out dot println. हाँ धन्यवाद. ठीक है. डिटेल्स सेंड कर देना. अभी कर दे, रात को जब भी जाके. ठीक है ना. बहुत ही बढ़िया, बहुत ही बढ़िया. ठीक है ब्रो, डन है. हाँ तू मुझे भेज दे. ठीक है. हेलो. अभी बता दूंगा. मैं क्लास ले लूँ. So sorry everyone. So Java linear is the main Java index out of bound 10 is reaching over there. So we're less than or equal to uh, so it should be, because we are working on to array, so it should be 0 to 10, or this should be also 0 to 10, not is equal to, because it is throwing in the exception, index out of bound exception. Hello, is it okay now or is it still low? Hello. Okay. Oh, so sorry. I'm just sitting a little bit far away. Right. So over here, the list of arrays 10 to 19. Right. And the number we were trying to search was 15 over here. We are trying to search 15. So 15 is found on 5th. Means 0, 1, 2, 3, 4, 5. So 15th is found on 5th position. So if we are going to search 18, so it will going to found us onto 8th position. So we'll again compile it or run it. So it found in 8th position. Now if we are trying to find 28, it is not available in the list. I'll explain. Compiled, run, number not found is the thing. So over here what we did, first we took an 10 size of array in integer, then we have took what to say, no, we are trying to initialize the number. Okay, we have enter some number into that part. What we did ki, okay, if we want to enter some number, so we have run a code like I plus 10 will be stored into AI. So for first AI is 0th position, in 0th position it will inserted 10. So if we have changed it to 100, it will be go as a 100 part, 100, 101, 102 and all those things, right? So we have make sure you can replace that part from system out.println to system.in, where you can take and ask user ki okay, please enter 10 number, and you can store 10 numbers into that array, then you can execute your program. So first loop is just initializing the array with the series that we want to insert, right? Then this array is printing that list. Okay, so when it was initialized, it is not going to see us. So now we have given the system out.println part, where we have printed all the sequence of the array. Okay, this is from 100 to 109, right? Now this is the number that we are taking to search in that list. You can take it from the again user also, ki please insert one number to search in the list. So you can take it from the user also, right? Now this is the main algorithm, this is the main program that we need to do. Over here what we did, okay, we have run a program from 0 to 10, the same loop, because we have to go from the 0th position to the 9th position. From 0 to 9th position we have to go. So every time it is going, it will checking okay, number is equal to AI. The same algorithm that we have written, ki number is equal to AI, because this number is replaced with the loop, right? So this loop go from 0 to 9. First time it will be A0. So if A0 position is equal to number, it will break, right? So whenever it will break below 10, right? So this loop will go on till the time maybe number is not found. If number is found, so the value of this I will be below 10, right? So if number is not found, and when we are going out from this loop, we are going out because if this I plus plus means the value of I will be 10, then we are going out from the loop. And after going out from the loop, we are checking कि okay, I is equal to 10 means this loop is exited normally without this break, means this loop will check from 0 to 9th. Till 9th the number is not found, it means number is not there, that is why I is 10. Else whatever is the situation is, if it is found on 0 to 9, it will going to print the index number. Okay, the index number is I and you have found that number on I. So what we are doing over here again, so if we are going to put it into this way, or maybe we are going to execute into a sorted part over here, because so on the loop, if loop is increasing from I part, right? So I is 0 1 2 3, number is, we are checking the number part with that also. So if number is matched with the like 35, and we will break, the value of I will be less than 9 or less than 10 basically. So we are going to print the value of I, means this is the index. If we are not going to match, क्योंकि if we are going to search 50, you know 550, so it will search, it will again increasing and increasing. After it will reach 9 and it will reach 10, the loop will break. The moment loop will break, the value of I will be 10. If value of I will be 10, it means the number is not found in the list. Got it? Or we need to again do it? If any one of you have any query. Yes, Shiven.
When we sort by changing the number from one by one, from greater to lower,
uh,
or lower to greater.
Right. So, sorting is a process where we sort, unorganized data or unplanned data in a specific order. So, I think a preferred order or specific order where, you know, not swapping adjacent that is bubble sort only. Sorting means so arranging the order in ascending or descending, or you can call it a specific order, or you call it a preferred order. So normally sorting happens in two way only, ascending and descending, where the first number is smallest and slowly gradually last number is the largest, or first number is the largest or slowly gradually last number is the smallest. So there is ascending and descending mode. Now there are five sorting algorithms. So bubble sort, selection sort, insertion sort, merge sort, and quick sort. So everyone has their own uniqueness, the things that they provide. So easiest one, starting one, was a bubble sort. Bubble sort was initialized, like the name was bubble put because how it worked, like in a water bubble, goes on the top, right? The same way, every time the iteration happens in bubble sort, the largest number will reach in the end of the list. That's how bubble sort work. So what they do, they compare adjacent element and swap them if they are in the wrong order. So if you look at the this data where there is a 6 4 1 2 5, so we'll look at the iteration 1 first. So 6 will check with the number 4, they checked, they are in wrong format, they swapped it. So 4 will be here, 6 will be here. Now we are not going to lose the this number 6. So 6 is here, 6 will get compared with the 1, it is again in the wrong order, again swapping happened. 6 then with 2, again 6 is the bigger than 2, again swapping happened. Now 6 will compare to the 5, and then it realized कि okay 6 is bigger, swapping happen. So in every iteration what will happen, the largest number will reach in the end of the list. So in iteration 1, 6 reached at the last position. Now we are believed कि okay 6 is already sorted, right? So we need to check the these 3 or 4 number. So now in this list 5 is already where he should be, right? So 4 will compare with the 1, swap it. 4 will compare to the 2, swap it. 4 will compare with the 5, right? And they are at the right position, so they are not going to swap because 4 is not bigger than 5. So sorting will not, swapping will not happen, right? So now if we look at this list, it means it shows us कि okay the list is sorted, right? But it is not going to stop over here because you don't know कि okay 1 or 2 is sorted or not. So it will do their iteration again, right? So it will check 1 with 2, okay, 1 is there, then 2 with the 4, okay, 2 is also at the right position, then it will check 1 with the 2 again, and it will say ki, okay, 1 is at the right position. So iteration will go on, right, till the time the list is sorted completely. Is there any query in bubble sort logic? Well, it's one of the easiest logic in sorting algorithms.
Sir, why 6 coming to right side?
Why?
6 is coming to right side.
In this process or which process? This one.
Yes,
So,
sir. Left
okay.
side.
So let's do it our own way. So what was the number? 6, 4, 1, 2, 5. So every time we will start bubble sort, we will capture the first index number. Okay, this is my k, or maybe some other, whatever you want to take it. Sorting means to arrange them in a order where it is sorted in a ascending manner or descending manner. Now what we will do, we will check 6 with the 4, which is bigger, 6 or 4,
6.
right? So 6 is bigger. Are they in the right right, or what to say, order? If we are arranging into ascending
No.
order, are they in right order?
Sir, what is descending order, sir? How
Okay,
can we arrange in descending
okay, okay,
order?
okay. So that, bro, what you are doing? ठीक है. So that was my fault also. Ascending and descending order. So ascending order means number is put into 1, 2, 3, 4, 5, 6. Right? If there is a list, it should be going to this format. Right? So first number is the smallest, and every number is, so the right side of every number is bigger than them. So if we look at 4, before 4 everyone is smaller than 4, and after 4 everyone is bigger than 4, right? Where descending order is where it is into reverse order, 6, 5, 4, 3, 2, 1. So this is a both are the sorted list in ascending order or descending order. Where we look at our this list, this is not in ascending order or descending order. There is no sorting happened with them. They are unsorted list. So 6 is coming before 4, then 4 is coming before 1, now 1 is coming before 2, right? So there is no proper order into that series. Okay, what is the process? Okay, is it into increasing order or decreasing order, right? Understood what is ascending and descending?
Sir, how to know we have to ascend ascending order or descending order?
Initially, if you get the
If
list, you can't decide it. So you have to run your sorted algorithm over there. So मतलब, if you want to check मतलब, the program, you want to check only कि okay, it is ascending or descending, you can check with sorting algorithm also. मतलब, you have to run loops कि okay, uh, in ascending order it is a basic rule कि for given number, before that number everyone should be small, and after that number everyone should be bigger, right? Like if we capture 3, before 3 everyone should be smaller than 3, and after 3 should be everyone is bigger than 3. This is the basic logic of ascending order. Same if we look at the descending order, so before 4 everyone should be bigger than 4, or after 4 everyone should be smaller than 4, and it should be, what to say, right for every element. So if you pick 2, this is right for 4 also, it is right for 2 also. If it is right for 2 also, it should be right for the 6 also, right? So that's what ascending and descending all about. So Abhi, what you doing? Look, if there is a guy in Btech or BCA, and they are asking, look, I don't say it is wrong or right, but yeah, look, ascending and descending order is, I think it is very basic, but yeah, I hope your query is resolved, or still there is a confusion.
No, sir. If a question is given that sort a or list, how we should which order we have to prefer, sir?
Okay, I'll explain.
Ascending order
Don't worry,
orders.
don't worry. Don't think that much. you first understand what is sorting. After that, we will decide if we need to do ascending or descending, right? First, we need to order all the list into ascending order. We are not going to focus on descending first of all, right? So, yeah. So, 6. So I hope everyone got clear. Now we will focus to create a program, and Abhi, your question we will take after the class 7:55 or 8 o'clock. We will try to so that other students will not wait for this ascending and descending, right? So we will make a program. I hope everyone else clear about the logic. Yeah. So we will take this in the last of it. So I'll make programming Java. You can do into Python or C C plus plus. It's not that a big deal. So let's import java.util.star so that we can use scanner class bubble sort 11. So public static void. So initially we'll take scanner class for the input from the user system.in where we'll create an array of let's create an array of 10 so that we can sort it out. So first let's tell user to enter it. So enter 10 numbers. So user will enter random numbers according to their choice, and it is our duty to sort it through bubble sort. So over here we are practicing it. So for int I is equal to 0, I till the time I know the length, so I less than 10, till the time we need to do plus plus. So sc dot next int the function, and here is ai is equal to, so that whole data will be captured over here. Now after entering we should print it also. So after that loop what we will do, we will print these numbers. So the number will be ai plus, so number will be printed. Now we just need to print that. So print ln to create the next line after this loop. So what we can do with this, copy space. So till now we have created two things. So is there any error? No, there is no error. So they asked me enter 10 number. I can enter 5, 9, 4, 55, 32, 100 or 60, 78, 90. So we are entering this 5, 9, the same series, the same sequence should be printed in a way so that we can see the iteration in future also. So now we will put the logic, the list is there, now we want to sort this list. So what we'll do, we'll run two loops, inner loop or outer loop. So I is equal to 0, I till the time less than 10, it should go I plus plus. Now we have to make sure कि okay, we will not going to cross the index limit also. So we will run second loop from 1. So int j is equal to 1, j till the time less than uh, 10 minus I, we should run it j plus plus. So the condition will be if again is it working? So we have to always check the adjacent number whatever sequence given. So a j minus 1 should be checked with the, if it is j minus 1 is greater than aj, right, the previous element is greater than the current element, it means we need to swap it. So swapping happen through a temporary variables. We can declare a temporary variable over here, uh, or maybe outside this loop also, because we should not declare any variable into a loop, so that otherwise the complexity, the time complexity will be bigger, or space complexity will be bigger also. So we have created temp over there. So now what is the work of temp? Temp should store one element initially, j minus 1, and j minus 1 will store aj, and now aj will store temporary value of aj minus 1 that was stored initially. So this is the way it should what to say, do the basic swapping. After that we need this to print it every iteration. So one way to use it like this key, okay, in one output we should know कि okay is it worked or not. So we have compiled the program. So you know, can some I am doing it myself, can somebody give me a series of 10 number also to sort?
Zero also you can take.
You can write it into in that chat box, so can I can pick it. So uh, okay, 2 3 7 9 11 40 50 70 80 500. So the whole list is sorted into ascending order, where they are from 2 is the smallest number and 500 is the largest number. So 1 2 3 4 5 6 7. Shivan, you have given only 7 digit. So let's do into another way, where every time we can see कि okay what is happening, what is the iteration is going on. So let's focus to put this into in this loop, so you can see कि okay how iteration is working. So over here we need to change the name of I, because over there we are into the loop where I is already there. So the life scope of I will fight with the another I. Z I Z Z Z Z Z. Right. Yeah. So we'll give. Don't worry. So 9 largest number. I think yes, we can try it. मतलब negative number is still a number. So let's first try the largest number first game. So 9. Oh, sorry. So let's compile first. So the series is 9 8 7 6 5 4 3 2 0 1. Right. So every time in first iteration, always remember in bubble sort, first iteration the largest number will reach in the end, right? So 9 was the largest number, it reached over there, and every time we will reduce the iteration also, right? Because we know कि okay 9 have reached, left the 9, 8 is reached, left the 8, right? So every time we will try to, you know, the largest number will reach in the end of the list, right? Now if you are want to check it, okay, is it working with the what to say, negative number. So 9 8 7 6 minus 10 minus 2 minus 5 where 90 95 96 or 42 So it is sorted on the negative number also. So minus 10 is the smallest number, right? So minus 10, minus 2 say, then it will reach to the 96. So that's how a bubble sort works, right? And bubble sort is literally one of the easiest sorting algorithm that is there. So I hope everyone should try today. So now we'll start selection sort. So selection sort is similar to bubble sort, but it is do different things. We can use any sorting for anything, no issues into it. So in terms of alphabet, we use it for the ASCII code. We can use ASCII codes in direct alphabet directly. So selection sort is someone that selects a number and put it onto the first place. So initially, in the first iteration, what it do, it search the minimum number from the list, right, and put it on the first index, minimum index, right. After that, it says ki okay, the first part is sorted because minimum number is at the zeroth position. Now I'll focus on the second part of the list, means from minimum index from 0 to 1 now, right. From this part to this part, it will again check the next minimum number. Okay, what is the minimum number into this part. So whatever the minimum number will be there, it will again shift it back to the fourth position, right. So now it will again check with the whole list with the next minimum number. Now again switching it back to the position of third. So now if we look at basic idea of it, कि what is selection sort do, like bubble sort used to do the biggest number in the end, where selection sort focus on minimum number at the first. So if there is a number of list like 10 or 2, 20, 1, 50, 5 and 6. So what it will do in first iteration, कि okay, this is the minimum index, 0 index 1, 2, 3, 4, 5, 6. So from whole list it will search the minimum number. So it found the minimum number on third position, it will swap with the 0th position number. So what will be the result of list after first iteration will be like this, where first will be at the first position, then second, then 20, then 10, then 50, then 5 and the 6. So it says ki okay, I'll try to first time reach minimum number at the 0th position. So first is sorted now. So now it will check from this place to this place ki which is the next minimum number. So now after checking, it will realize ki okay, second is itself the minimum number. So it will swap it to its own position. So in second iteration, the same result will come again. In third iteration, where it will say ki okay, this part is already sorted from 20 to last. What is the next minimum number? So it will check from 20, right. So 10 is a small number, 50 is a bigger number, 5 is a small, 6 is bigger, right. So the minimum number it will found is 5. Now it will replace 5 and 20. So in third iteration, 1, 2, 5, 10, 50, 20 and 6. In third iteration, this will be the list that we are looking at. So it will say ki okay, this list is sorted. Now I'll check from this part. So when it will start from 10 to 6, it will found ki okay, 6 is the minimum number. So it will swap it with the this. So next 1, 2, 5, 6, 50, 20 and 10. So this list is sorted. Now we can see ki okay, this 1, 2, 5, 6 means first part of this array is sorted. Second part of array is again we will apply selection sort. So 50, 20, 10. So the minimum number will be 10, 20 and 50. So it will continue for 20 and 50 also. But yeah, with this iteration we will get our list sorted. Because in each iteration we are getting our minimum number at the first position. So that's how selection sort works. Selection sort focus on selecting the minimum number and swapping it with the minimum index. क्योंकि what is the minimum index we are using. uh, is the logic is clear? क्योंकि this is the basic logic of selection sort, so that we can go ahead for the programming part. Can someone confirm? Ajay, Krishna, Saurabh, Pushala Bharat. So, Pushala Bharat, what is your question? Bubble sort is used for sorting the alphabet. I okay. So, let's make it the program. So, there is two way to create this program. I will try to explain both. So first we will import java.util package so that we can take input from the user. So class selection sort 15. So public static void main. So we will make the object of scanner class so that we can take input. So now what we will do, we will take input from the user in the array arr 10. So after choosing array, we will take instruction to the user, please enter 10 number. So after giving the instruction to the user, we will start scanning it. So from we'll run a loop. So I to 10, I plus plus, because size of array is 10, so we can directly write 10 over here. So arr I will be scanning that sc dot next int is the function to scan the integers number. After scanning, we can put our algorithm to the work, where we need to work with two arrays. Int I is equal to 0 till the time I is less than 10, I plus plus. The second loop will be j, so int j is equal to I plus 1, so that we will start from the second index, right? So I is working on the 0th index and j should be start from the next index of the I, right? So j till the time less than 10 say j plus plus. So after that what we'll do, we need a one condition where we say ki okay arr I is bigger than arr j, so we need to swap them. So int temp is equal to what to say, int temp is equal to arr I is equal to arr j and arr j is equal to temp. So we have swapped those number. The program is done. Now we will put output to this program. After sorting, so arr I plus so we will remove print ln, we will use only print, so that next line will be there, not be there in every element. So now we'll save it. So let's try to compile this program. So selection sort is compiled. So enter 10 number 20, 50, 60, 5, 4, 3, 8, 9, 2, 1. So after sorting, if you look at the series 1, 2, 3, 4, 5, 8, 9, 20, 50, 60, the list is sorted, right? Now we will put flag loops also, so that we can see okay, what is happening with each iteration, is it going right or wrong, right? So what we'll do, we will pick this the same printing method in the outer loop, not in the inner loop but in the outer loop. Now we need to change this what to say flag with z also, so that we will not clash with the I, because the outer loop is working with the I already. So yeah, this is compiled. We'll run again. So same 20 50 60 5 4 3 8 9 2 1. So this is what happening uh, with each iteration: 1 2 3 4 5 8 9 20 50 60. With each iteration we can see ki okay, the minimum number is coming at the first index, second minimum number is coming at the second index with each iteration, right? So when 1 is there, 2 is not here, 2 is in the last. In second iteration 2 reached at its right position. In third iteration 3 will reach at its right position. In fourth iteration 4 will reach at its right position. So that's how we implement selection sort, or which each iteration we are sorting it out. If we look at mid of the array or mid of the iteration, okay, first half of this array is sorted 1 2 3 4 5, second half of array is not sorted, right? So that's how selection sort works. Okay, slowly with each iteration it is sorting the first half of the array and picking up the value from the second half of the array to put it at the right position, right? So is it clear what we are doing over here? Or is it confusing? Is there any query? Can someone confirm? Saurabh? Okay, clear. So, but this is not the right selection sort. What I can say, because we are swapping it every time. So if you look at this, you know, whole story, what we can see ki okay, every time the second last number will reach at the last position. Okay, when one is here, two is here, two is here, three is here, three is here, four is here in the last position. Why it is happening? Because we are swapping the number each time in the loop. Now what we can do, there is one more way to do it. Let's put it into the one more way to do this. So like one is selection sort 16. So what is the next way to do it? Okay, we will not going to swap it in the inner loop, we will going to swap it in the outer loop. So take a new number index, we will save it with the I, right? And we will cut this swapping part inside, right? And we will tell you okay, when I is greater than, index is greater than arrj, because we are not swapping right now, what will it will do? So every time it is uh, index is greater than arrj, right? So index is greater than arrj, we will swap it, not swap it, we will just save the jth value in the index. And after the inner loop, what we will do, we will swap those numbers. So we will swap a temp with the index, and index so we need to, what we need to do, I, okay, so we need to swap, because index is holding the value of last minimum number. So we will swap it index with the I, and work is done already. So now if we try to run this sort selection sort 16, what will happen? Every time last number, second last number will not reach in the end. So we will run it with the same thing, Java C. So we will try to input the same number and we can see what is the difference between those two: 20, 50, 60, 5, 4, 3, 8, 9, 2, 1. So what we can see, you know, first part is sorting directly, like 1 2 3 4 5. It was sorted in the same fashion because 1 2 3 4 5 6, right? It was starting, 6 was not there, so it was started sorting from here. But we can see the second part of it कि okay, the second last number is not reaching in the end, where 2 3 4 5 8 9 20 50 60 all will reach in the end. This will not going to swap it according to that. First part swapping happening in the same fashion, but second part it will leave. Why? Because we are not swapping into every inner iteration. We are swapping after the first iteration will complete कि okay, when the we have found the right index कि okay, this is the minimum index, right? Then we will swap it with the zeroth position, where what we doing over here with the this algorithm, this selection sort algorithm, we are shifting it every time when we will find a minimum number. So we will find another minimum number, then we swap it, then another minimum number, then we swap it. Over here we are not doing the same. What we are saying कि okay, just find the minimum number, we don't want to swap every time. So when we found the every minimum number in the index, right, then we will swap that index with the I, right? That's the correct way of doing it. So there is a two way to do selection sort, both are correct, right? But this way is better. Why? Because we are doing the less swapping in this scenario, or that's the goal of an algorithm, to create efficiency, right? So is there any query? So again, insertion sort algorithm. Insertion sort is a simple and intuitive comparison-based sorting algorithm that builds a sorted array by iteratively inserting element into their correct position. So it is again one of the simple algorithm. It is not very efficient algorithm, but yeah, it can work well with the small data set, right? So if we look at this example where we got a list of 7 4 5 2, over here in session sort, just imagine कि okay, the first part, the first element is sorted itself, right? So we have to focus from second element to the last element. Now what we will do, we will check कि okay, 4, we need to put 4 at its right position. So we will check 4 with the 7. So if 7 is bigger than 4, we will swap it, right? So first, in first iteration, what we will get, 4 7 5 2. Now if we look at this array, first half is sorted, 4 and 7 is the right, at the right places. So what they do need to do now, we need to check 5 now. Okay, we need to insert 5 in the right position. So 5 will check itself with the 7. So 7 is bigger than 5, so they will swap. 5 will then check with the 4. 4 is not greater than 5, so means it is at the right position. So after third step, what will be the result? 4 5 7 2, right? Now if we look at the, remove the part of 2, 4 5 7 is in the right, order, right? Now we will have to check through 2. So 2 will get checked with 7. Okay, 2 is still smaller, it will swap. Then it will swap with 5, then it will swap with the 4 also, because it is the smallest element. So all three elements will shift right to give space to the 2. So the final result will be 2 4 5 7. So we'll try to elaborate that more with that. So if we will need to put some example like 10 5 80 4 and maybe some other example of 1, right? So if we get an example of 5 element, what we need to do, ki first forget about this. 10 is at its right position, right? It will divide 10 and other parts, right? So we will pick the first element after 10. We will check it with the 10 कि okay, 5 is greater than 10 or not, or 10 is greater than 5 or not. If 10 is greater than 5, we need to swap them. So 5 will come over here, 10 will come over here, then 80, then 4, then 1. Now it will say कि okay 5 and 10 is at the right position. Now we will check 80. So it will check 80 कि okay 10 is greater than 80. No, it means there is no need to change anyone. So after this step 80, 4 and 1. So this is sorted part. Now we will check 4. 4 will check with this. They'll say कि okay 4 is smaller than 80. So 4 will be here, then 80 will be here. Then 4 will be checked with the 10. Then 10 is again that. So 4 will be here and 10 will be here. Right. Then again 4 will be checked with the 5. It will again replace swap. So 4 will be here, 5 will be here. So what is the correct position of 4? So 4, 5, 10, 80 and 1. Now this part of the array is sorted clearly. So 4, 5, 10, 80 and 1 is there. Now we will check 1 because 1 is smaller than this, this and this. Right. So they all will shift to right and they'll make space for 1. So 1, 4, 5, 10, 80. So this will be the last result of insertion sort, and that's the way the insertion sort works. So if we look at the algorithm of insertion sort, it says start with the second element assuming the first element is already sorted. Compare the current element with its adjacent elements. Compare the element with the adjacent element. If current element is smaller than the adjacent element, means if the current element that we are looking at 5 is smaller than adjacent element, the previous element, right, it will swap, right? So repeat this process until the current element is in the correct position. We have to repeat this position so that the current element will reach at its correct position. Now move on to the next unsorted element. When the one element is sorted, move on to the next element that need to be sorted and repeat step 2 to 4, 2, 3 and 4 until the entire array is sorted. So this is the algorithm of selection sort. So the logic of selection sort is clear. Can someone confirm?
Yes, sir.
Okay. So let's make a program. So we will pick out few things from there only. Why to waste my? So we have picked only basic part where we have imported util package. We have given the class name, public static void main starting, and we are taking 10 array input from the user where we are created the object of scanner class. Then we have created array of 10 length or 10 elements. Then we have told the user please enter 10 number. Then we have started the loop from 0 to 9 and we have taken input through scanner class function sc.nextInt, and we have took the input of 10 elements from the user. Now there is one thing that we need to do. So we need to print this part before sorting also. Before sorting, where what we need to do, we need to print arr I spaces, and this needs to be here, and you can use what to say backslash n also for the next line in print part. Remove the println from here and println after the array loop, right? So now before sorting, this will be the result. And now what we need to do, we need to start. So we will always start from the index number 1, means second element of the array, because insertion sort believes कि first part is already sorted. So int whatever you want to name it, I till the time less than 10. 10 is the length of the array. You can use arr length also over there. So I plus plus. So over here you need to took two things. One, key. So in key you need to store arr I and int j is equal to I minus 1, so that you can pick the previous element of key element, right? So now the inner loop will be till the time j is greater than is equal to 0 and arr j is greater than key element, till the time they need to traverse the loop, where what we need to do, we will do ki okay, swap them arr j plus 1 will be shifting the right shifting every element that is agreeing with the condition. Okay, and we need to set j is equal to j minus 1, so that we can shift ourselves to the left side of the list. Okay, we are checking every element in the left side of the loop. After this loop, what we need to do, okay, arr j is broken. After this loop, j is equal to key, and after that what we need to do, okay, so key is stored over there and arr j is getting minus, then arr j is equal to key. I think it is done. The key is there, then I think, yeah. Is there anything missing into it? Arr j key. So j plus 1, okay, that's the only difference that we need to do. And the loop is closed. Now after the sort program, so the program is done for that. We will save it. So there are few errors while j greater than over here. What we need to do, where the loop, I am doing it as it was for loop, so it is a while loop. There is no need to put that semicolon over there. So there is one more error while parsing reached end of the file, where the error is while is started here, ended here, for is started here, ended here in session sort.java 54. Okay, so public static void main is closed. Then we need to close class file also. Now it is compiled. Let's run it. So enter 10, 40, 50, 4, 3, 2, 80, 66, 44, 33. So after sorting 2, 3, 4, 10, is my voice is audible? Okay. So 2, 3, 4, 10, 33, 40, 44, 50, 66, 80. Then we can see the list is sorted. Is it clear how it is working? And we are also doing one more thing. Okay, let's focus to create flags, क्योंकि how iteration is happening. So just pick it up this loop again and enter it after the swapping part in the loop, where you can declare integer z, so that it will not clash with the internal I variable. So z is there. Save it. Let's compile it again and let's execute it. So we will put the same number again: 10, 40, 50, 4, 3, 2, 80, 66, 44, 33. So this will be the whole iteration. कि okay how this algorithm is doing its work. So if you look at that 10 40 50, so first three element is sorted according to the condition, right? So there is no difference in between. So if you look at the first iteration uh, and the second iteration also, there is no difference. Why? Because 10 40 and 50 first three elements are there at right position. So now we'll start with the 4, okay, 4 will check with the 50, then 40, then 10, and they all will be swapped and 4 will be at their right position in this list. Okay, then 3 will come, then 3 will be swapped again, then 2 will come, 2 will be swapped again to its right position. Now 80 will come, they will leave it. When 66 come, so what they do after 80, they'll check with the 80 and they swapped it. They know कि okay what is the right position, right? So 66 will be after 50 and in between 80. Now 44, so 44 will be entered between 40 and 50. So they are checking with 80, 80 will be swapped, then 66 will be swapped, then 50 will be swapped, and 44 will be at the right position. Then chance of 33, so 33 will be reached in between 10 to 40. So all elements will be swapped to right shift, where 33 will be reached at its right position. So that's how this insertion sort is working. क्योंकि they are when treating a key, right? So if you look at the programming part of this, what they are doing, क्योंकि we are taking arr I as a key. So in first time the first element will be the key. We are checking two conditions only, कि okay j will be should be greater than 0. If we will not check this condition, in last class we have what we did, कि this condition was moved after this end. Okay, so this condition should be first, कि okay j is greater than is equal to 0 and arr j is greater than key. What is the value of arr j? So arr j is I minus 1. So I will be 1 and arr j will be arr 0, right? So they are checking left side of the list every time, right? So if it is true, then what they'll do, they'll shifting the element one side righter, क्योंकि arr j will be go to arr j plus 1. So they'll shift every element on their right side, right? And j is equal to then j minus 1, and till the time the loop is going on, they are shifting every element to the right side. The moment shift will complete, what will happen, because after this there will be j minus 1. So we will set the j plus 1 key, right? So that the right element will be reaching at their right index number, right? So these are the basic things in insertion sort. So these two logics you need to practice it again, क्योंकि we need to you can do it into right shift, and even you can do it into reverse also. So I'll suggest कि when you are doing your practice, do one to the left shift also, क्योंकि how to create a reverse insertion sort. So first, what is merge sort? So merge sort is a divide and conquer algorithm that works by dividing the input array into two halves, recursively sorting each half, then merging the sorted halves to produce a sorted array. So it means it just works on divide and conquer concept that we used to do in binary search also. We take an array, we divide it into two parts, then recursively divide, means we will divide them till the time they will not left with one element only. So after one element we will start merge them back, and while merging we will make sure कि okay every half will stay sorted, right? So if you look at the explanation, the divide, the input array is divided into two halves which are recursively divided further. Each subarray contains only one element. So we have to divide array till the time one element is left in each subarray. Conquer, the individual elements are considered sorted. So every individual element are sorted itself, right? So the algorithm recursively sort each half of the divided array. Merge, the sorted halves are merged back together to form a single sorted array, right? So we'll try to explain you. So stay together in this. otherwise you will be lost. So look at array. So yeah, so there is a number 6, 60, 5, 45, 4, 30, right? So look at this array. First, what we will do, we will divide this array into two parts. So left and right. So there will be two, three things in this array, left and right. Uh, when we divide into two part, it will be showing us like this two, 6, 65. The right part will be 45, 4, 30. Then, oh shit. So just, I think it got closed. Yeah, so we were here. Right, so we were here. So we have divided this array into two subpart, left and right. Then we will divide it further. So if we will try to divide 665, what will happen? It will be divided into two parts. One is 6 only, and the second is 60 and 5. Same if we will try to do this with here. So first part will be 45, the second part will be 4 and 30. Then we will divide it more further. Six will be alone, then 60 will be alone, then 5 will be alone. Over here 45 will be alone, 4 will be alone, and 30 will be alone. Now everything is divided into single part, and now the algorithm says कि okay, each part is sorted by itself, right? So when there is a one element, it is already sorted, right? Because there is nothing to compare. Now what we will do, we'll try to merge them back again together. So the way we were divided them, right, left right left right left right, the same way we'll try to merge them back, right? So first if we look at this part, okay, if we'll try to merge back 660 or 60 or 5, so everything is a left and right. If we'll try to compare each and every one of them, okay, how to do it? So first let's do it for them, okay, 60 and 5. They'll compare with each other, okay, 60 is greater than 5, no, 60 is not greater than 5, so 5 will come before 60, right, and 6 will be here. Now we'll try to again try to merge them back together. So we will check okay, 6 is greater than 5, yes it is greater than 5. So in a new array, that will be 3 array, 5 will come before, so 5 will here. Now 6 will check with the 60 also, which is greater and smaller. The moment we realize okay, 6 is smaller, we will put 6 over here, then 60 will come automatically over here. The same we will try to do with the another half of the array. What we will do, first we will merge them back together. 45 is at its right position, 4 3 will be at the right position, so 4 and 30. And when we will try to merge them back together, what will happen? So 40 is greater than 4, true. So in a new the list, so 4 will come before 45. Then it will check if 45 is greater than 30. Yeah, it is also true because 45 is greater, so 30 will also come over here, 30 and 45. So we got the two sub array that is already sorted, 5 6 60, 4, 30 and 45, right? So now when we will try to do it, what we will do, so keep it I, keep it j, and they both start with 0, right? And they have the ending. So we will check ki, okay, the left array I is greater than or is equal to, greater than or less than, whatever you want to put it, that's not the logic main. So right, so write j, right? So left I is greater than j, right j. So 4 I 5 is greater than 4, no it is not. So what it will do, so we are trying to merge it back now, right? So it is not, so we will come from this part, क्योंकि 4 will be here. So when 4 will come over here, what we will do, we will do j plus plus. Now 5 will be compared with the 30, which is bigger, right? So 5 will come over there because 5 is smaller, 5 will come over here, we will do I plus plus. Now 6 will be compared with the 30, right? So 6 is smaller, 30 is smaller, 6 is smaller, so 6 will come and we will do again I plus plus. From which array or which sub array we are taking the element, we will try to plus plus that element's flag only, or index or key, whatever you want to call it. So we will take 6, then I plus plus. Now there is only one element left over here, that is 60. There is two element left, there is 30 and 40. So 60 will be compared with 30, 30 will come over here, we will do j plus plus. Then 60 will be compared with 45, 45 will come over here. This array is gone, the whole element is shifted over here, only one element left over here also, 60. So we will directly transfer 62 over here. So now the list is sorted 4, 5, 6, 30, 45, 60. So that's how merge sort works. So they first divide the list into smaller parts, right? Then start merging it back to a sorted list. I hope the logic is cleared. What is the idea of merge sort? Please confirm.
Yes, sir.
Okay, so let's stay together into this. So now I'll show you the program. I'll give you the program to make it also. There you want to change it because program is little bit bigger. So I don't create it from scratch right now. So over here we run program again. What we understood, 2 3 things. One, we need recursive function where we do the part of divide. For divide part we need recursive function, right? So what we do over here, we created an array, we printed the original array, and we called the method called merge sort. So merge sort method will be called over here. So merge sort is this method where we have shifted our array. The merge sort work, this function's main work to divide the array into smaller part. So over here we printing the array because we have already put this example. So we have took the length of the array, and if n is greater than 1, till the time n is greater than 1, this condition will be true, right? We divided the array from middle. We said ki okay, n divided by 2 will be the mid value, and we have created two sub array, integer left and integer right. So integer left will be the size of integer left will be integer mid. What is the if 6 is divided by 2, it is 3, and the rest of right will be n minus mid, so that if there is a 7 or there is an odd number, it will be divided correctly, right? So then we can copy those data to into left array and right array. So you can temporarily copy the data. So array from 0 to mid, will start into that part, right? So the left array from 0 to mid part will be copied into the left part, and from mid plus 1 to end will be copied into the right part, right? So we have divided those array to into two smaller array, left and right. Now we have did the recursive calling. So we called this same method that we are going through with the left part, then with the right part, right? So same recursion will happen every time. So left part then divided into left and right, then again they will be called for left and right till the time every element will reach to the n is, this condition will break only when then it will be equal to 1 only, the size of array will be n only, right? So in each sub array there will be one element only. Till that time this will be start recursively breaking or dividing the array into smaller pieces. After that, when it is breaked into the smaller pieces, we have called the merge. So in merge we are sending three things: array and left and right, right? So we have sent the three arrays into the merge part. Now merge part is important part. Why? The array is broken up. Now we have to merge it back to create a full array. So if you look at in merge function, what we are trying to do, uh, we have took the length of left and took the length of right. After that we have created three, again I, j and k, for three variables, three arrays indexes, right? While I is less than n1, right? So n1 is length of left array and n2 is length of right array. Till the time I is less than its n1 or j is less than n2, this loop will go on, right? So what this loop will do, this loop will do if left I is less than is equal to right j, right? So left I is less than is equal to right j, it is comparing first position with the first position over here. So if it is true, it is saying ki in arr k, the main array k will be stored arr I. So in main array 0th position this will be stored, whichever is smaller, right? And do the I plus plus. So if we are taking value from I part or left part, we will do I plus plus. If we are taking value from right part or j part, we will do j plus plus. And k will be plus plus after this if condition only. Because when one element came into over here, then we will shift it back to k plus plus. No, to shifting back to next array length, right? So we will do this exercise again and again till the time all the element will be copied over here. If there will be a chance, right, there will be a chance then where you can say ki okay, 40 or maybe 30, 40, 50, or over here was 5, 6, 7, right? So when you are trying to merge them back, so 5, 6, 7 was all came over here but no element came from over here, right? In that moment, because the condition is in a such a way ki okay, if j is less than n2 breaks it, this loop will be break, because they both have to be, it is an AND condition, so they both have to be true, right? The moment it will break, so we understood ki okay, the whole element come over here and this list is already sorted. What we will do, we will do copy remaining element of left or copy remaining element of right. So we will copy it continuously 40, 50. There is no need to do the conditioning. Just put an arr k is equal to left I and I plus plus k plus plus, right? So we will do this direct value over there, right? So copy remaining element of left or copy remaining element of right if this loop breaks, right? So that's how we got our full-fledged sorted array over here. So there are a lot of printing part we have done into over here. So we'll try to remove this. There is no need to do it. Initial level first we'll run it. So I hope the basic idea is clear what we are trying to do. Right. So So the original array was 12, 11, 13, 5, 6, 7, and the sorted array is 5, 6, 7, 11, 12, 13. Right. Now we will try to print maximum flags. Right. So we will pick this print array and we will be printing this over here. Whenever the recursion will happen, So whenever recursion is coming, we are trying to print it. We are printing the divide part of the loop. So if you see, it is divided into two parts, 12, 11, 13. Then it is divided into two part again, 12 is alone, 11, 13 together. Now it will again divide 11, 13. Now 11, 13 is also alone, right? A single element. Then again 5, 6, 7 is also broken, 5, 6, 7 to 5, then 6, 7, then 6, 7, right? So you can take this to one more thing, like we'll put one more position, so it is 6. Now we will say कि, okay, there will be an uh, 16 over here. So we'll try to compile this, right? So 12, 11, 13 over here, 5, 6, 7, 16. So 5, 6 is divided together, then 6, 7 or 6 was divided together. So that is how it is dividing the array. That's our part of divide, right? Now the second print part, we will try to put it into merge back to main array. Now there are multiple merging happening. One merge is happening over here, then remaining merge will happening over here, right? So what we can do, we can put it over here, and we can put it over here also. So it will be little bit messy, but yeah, you can get a basic idea कि okay, what is happening with the merging part, right? So uh, till that part we were dividing. Now we are starting merging, so 5, 6, 7, 16. So 7, 16 was merged, then 5, 6 was merged over here, right? So over till this part, 12 and 13, 12 and 13. So we are merging the same part also, because each part merge will also get called. So first we will merge back to 11, 12, 13. We have divided 11, 12, 13, 12, 11, 13. Then we have sorted them to 11, 12, 13. Then 5, 6, 7, 16 was divided. Then they also got merged back. Now we got the two array till this condition. That is one is 11, 12, 13, and second is 5, 6, 7, 16. Right. So now with each list, okay, 5 is compared with what? 5 got compared with the 11. So 5 will be here now, right? Then each element start replacing them in the first part, because we have saved the element into left and right. It was stored over there, right? In each comparison, every element is getting replaced. So 5, 6, 7. Now we left with 5, 6, 7, 16. Right, now 11 will be there, then 12 will be there, then 13 will be there, and 16 will be there. So from those two arrays, we are taking each and every element and putting them on their right position. So after this iteration, we got the 5, 6, 7, 11, 12, 13, 16. So yeah, this is the basic idea of you know merge sort that works on to divide and conquer. I hope it is clear. If you have any question, you can ask. So what is a linked list first of all? So linked list is a data structure used to store a collection of elements where each element is contained within a node. Each node in a linked list holds two pieces of information: the actual data and also the reference or pointer to the next sequence. The last node in the list typically points to the specific value like null or none. Right. So what is a node first of all? If you look at data structure and the way data structure is working, uh, initial level, if we see there was one data structure that we used to contain a lot of element, that was array. So what array used to do, array will use a sequential way of storing data, and it's in static way. Okay, when you are declaring an array, you have to declare कि okay, the length will be array will be arr 5, right? And you can store data like 10, 20, 30, 40, 50 on the basis of their index number, and you can directly access any index number directly. But what is a linked list? Linked list is a dynamic way of storing data where you only focus on one part, that is node, right? Node contains two things: one is data and one is reference to the next node. If in any list there will be a last node that contains only null, right? So when you start a list, you start with the head part only, क्योंकि if there is a head or there is an what to say, head will only denote to one first node that we are going to store, क्योंकि if there is a 10 and there is an in next, there is a null value, right? If there is a only one node in a linked list, so it will look like this: head will directly point out to the first node, right? And the same way, if there is a multiple, if we want to enter 20, what we need to do? We need to check कि okay, which node stores null. The moment a node store null, what we do? We will point out the next node to this only, क्योंकि store 20 over here, null over here, and remove this null from this part. This will be the reference to the 20, reference of 20 node, right? So that's how a linked list is created. Linked list mainly focus on dynamic memory allocation. Linked list, there are few, what to say, linked list advantage and disadvantages. Dynamic size: linked list can easily grow or shrink in size during program execution. Means memory allocation is you can dynamically allocate memory and remove a memory also, right? So second, easy insertion and deletion. So you can insert easily and delete also from linked list, and no need for continuous memory, right? So unlike array, linked list can be scattered in memory. Means there is no particular memory location, they all are connected through their references, next references, right? Disadvantage: random access is slow. Why? Because in array you can directly access last element through ARR 5 or ARR 4, but in linked list it is not possible. You have to traverse the whole part yourself, क्योंकि if you want to access C, you have to go through A, then B, then C. That is how you go to the next node. Additional memory: in array we only store the values, but in linked list we have to store the reference also, क्योंकि in every part there is an, other than data, there is a reference part, क्योंकि reference that is going to the next node. So we have to store the reference also into additional memory. So these are the advantages and disadvantages of linked list. How to implement? Let's go into it. Is it clear till now what is idea? Ajay, Rutuja, Mayuri, Sai Kiran, is it clear what we tried to explain, or is there a confusion? Okay, it is clear. So now we'll try to implement this. So first of all, what we need to do, we need to create a node class. So class node, where you need to take two things: int data and same with the reference of node next. And when there is an so this dot data is equal to data, and this dot next is equal to null. That's how a new node is created. So when we create the new node, what we need to do, this is the node. Now we will create the linked list. Class linked list 1. So over here we need to do, perform few actions, that is like create an object of node, that is head, and make sure when we will create the object of linked list, we should in constructor part, what we do, put head to the null, right? Now we have to create a function for insertion and a function for display, right? So in insertion, what we need to do, we need to check, okay, void insert and data, int data, that whatever data is coming. In insertion time, what we need to check first of all, if, and we'll create the new new node is equal to new node, and transfer this data to that, so that it can be stored over here, this data, right? So if head is equal to null, means the list is empty till now, there is no first entry, so we will be like entering, put head is equal to the new node, right? So we need to make sure कि we have the value of or reference of first node. Why? Because if we don't know the reference of first node, then it will be scattered, we should not know, right? So in every linked list we need to capture the value of head, क्योंकि where is the head is pointing out, so we should know it, because that's how you start the linked list. Linked list will always start from the head part, right? So if is null, there is no linked list. If head is null, so we will put one first linked list to the head only. If head is not null, there is a scenario, if we try to insert a value, there is another scenario where head is not null. So what we will do over here, create a current that will denote to the head, and then run a while loop. While loop will be like, if current dot next not equal to null, till the time this loop should run, and current will go to the current dot next, right? And after this loop, we will, if we want to insert e, right, in this list, what do we need to do? We need to check ki, okay, where is the null. So till the time there is no null into next, so next is pointing out to b, right? Then this next is pointing out to c, this c is pointing out to d. If there is a null, means we need to insert the new node over here, so that we can easily uh, so whenever we'll try to insert the new node over here, what we'll do, right, we will insert over here, and this null will be pointing out to this only. So this we have to do with our in this scenario, where what we'll do, current dot next is equal to new node, right? So that's the way we should insert it. After that, what we need to do, the insertion function is complete, we need to do display function. So in display function, what we will do, we will start from the head, we will create one more new node, same current node, current is equal to head, and till the time while current dot next not equal to null, so we need to print system dot out dot println, and what to say, we need to insert current dot data plus the space, so we'll remove println, so print only. So till the time it is there, it will execute. Now we will create our class test linked list, where we will create our public static void main. So we will create our public static void main, and over here what we need to do, we need to create the object of linked list, linked list 1 L2 is equal to new linked list list 1. So we have created the object of linked list L2 dot insert 100. So we'll try to insert 2 3 number, insert 200 L2 dot insert 300. Now we'll try to display it L2 dot display. So let's execute this. There will be few errors. So let's compile this. So there are a lot of errors, like over here we have put the wrong. So this is wrong, then this is wrong, and L2 dot insert, L2 dot insert. So linked list 1 is the right declaration where we have done it wrong. So linked list. So line number 17, there is an okay. So the constructor name should be equals to the class name. That was a mistake over here. So again there is an error, cannot find symbol head. Why? Because we have uh, changed the value of head to H should be capital. We have created head over here. Head is null into data. Head is equal to null head current head dot next current. Again, so in display it should be head. So still there are a lot of errors. Cannot find symbol new node. So in this part, if you go over here, new node should be this. New node. So head is equal to new node, cannot find symbol. Method new node, current dot next. Okay, so over here what we did wrong, we did the so Java is, you all know, is a hardbound languages where you have to make sure कि okay everything is inside it. The cannot find symbol head is equal to new node. Node is equal to new node, head is equal to null. So head is equal to new node. Head is equal to null. Okay, so there is no round bracket required over here. Java test linked linked list 1. So loop is going on, there is no breakage to the loop. So in display there is something went wrong. Where the current next is not equal to null. It is printing the data current dot data, and in while current dot is equal to current dot next. So 100 200 is there, and then 300 didn't make it over here. Right, so this is the way that we use linked list. Right, initially you will face little bit issues like this in linked list when you do programming in Java. So other languages will be safer for you if you will start from there. Dot next not equal to null. So yeah, that was the initial idea of Java. So any query regarding this, कि okay, what you have understood or what you have not understood? Okay, direct current, not next. We used to use, so we can directly use current over here. That's the difference. So now 100 200 300 all are coming. So yeah, this is the basic how to create linked list. First, you have to remember the node always. है ना? The basic idea of a linked list is node where you store two values, a data or a reference of next. Right? The way you store and data and reference to the next is how you are going to manage linked list. So any query regarding this or any confusion? Okay, what is the use of linked list over array? Uh, when you do dynamic programming, right? You can't decide कि okay, you are creating a software for 1,000 students or 1,000 employees for a company. After a certain period of time, array will be fully used, right? So if there is you create an array of 100 or 200, and 300 value came in, how array is going to handle it? Right, that's not possible. In dynamic time, you are not going to change the indexing of array, right? So linked list come into dynamic programming where you don't want to okay, what is the highest number? You can store n number of values over here in dynamically. Initially we have not declared कि okay, the size of linked list is 1 or 2, it doesn't matter, it will go on. Every time you insert something, you create a new node or you insert it over there. So yeah, that was the initial use of linked list कि okay, it is dynamic, it is not static. First of all, कि you declare the indexing like 10 20 30, it's not going work like that. You can insert n number of values while dynamic programming. While running, it will decide कि okay, we need to enter more. You can enter more number. If you don't want to, you don't need to, and you can delete also. So you have stored 1 lakh data, but now you don't require 1 lakh data, and you only require two numbers only. So you can delete everything. In array you cannot, because you have already taken the space, right? So if you are declaring a array of 200 number and you are storing two number only, so it is waste of memory also, right? So that is why linked list is there. Yeah. So any query? So please practice linked list, because in future, when trees are coming, when graphs are coming, you need to know linked list at least. So we will continue tomorrow, Monday. In Monday, so what is circular linked list? Circular linked list is a sequence of element in which each node has a link to the next node, and the last node is having a link to the first node. So that is the difference between normal linked list and circular linked list. Over here, the last node doesn't contain null, it contains the reference to the first node or the head node over here, right? And circular linked list are two types: single circular list and doubly circular linked list. And doubly circular linked list, you find कि okay, the last node is storing the reference for the first node, and the first node's previous is storing the address of the last node. Right, so these are the two differences between you know normal linked list and circular linked list. So we study two type of circular linked list, a single and the doubly circular linked list. If we look at initially the single circular linked list, over here you can see कि okay, if there is a one stores the address of two, two stores the address of three, but three will store the address of head one, the first linked list or first node that we created, right? In a similar fashion, the memory representation of a circular linked list look like this. Over there, normally if it was not a circular one, the last node will be stored the address of null, right? But this is storing the address for the first one. Okay, this is the our first address of the linked list or node, right? So if you look at the basic example, okay, how we do it. So if we are creating a linked list in first, it is storing the data for the second, this is the storing for the third, right? Third will take care of it, and this is our head also, right? So this is our idea of circular linked list. Now we need to create two three things with the circular linked list. First, we need to insert values. Second, we need to view all the things. Third, we need to delete a particular node also, right? So in that scenario, how we do it? So insertion creates three things. Okay, in insertion there are two or three scenario. First scenario is insertion, like if head value is null, if head is equal to null, it means till now all the what to say list is empty, there is no node in the list. So what we do, we'll create a new node, and we will heading out, head will automatically store the address of the new node. It means this is the first node into our linked list. Then second, if there is a second node we need to create, okay, if we have created our first node, first is created, head is addressing out to this node, and this is in the first scenario also there is a one requirement in the circular linked list, because the one first will also store the address of itself now. Then we need to insert one more number 2. So then what we do, okay, first will be addressing to this, and this will be addressing to the first one. If we are storing one more node, then what we need to do, 3 will be pointing out to this, and 3 is next will be pointing out to the head node. So these are the scenarios that we need to take care while inserting a number or inserting a node into a circular linked list, a single circular linked list. So let's look at the example ki, okay, how we are going to do it. So let's create a node, node 3. A node will be created in Java as a class. So class contains two. We are creating single one this time. So int data and node 3 next. So when we creating these, so while executing the constructor, we need to take the data, what data we need to create with the node, and this dot data, whatever data we are receiving from the user side, what we need to do, we need to insert that data into this dot data, so that node contains the data that we are trying to insert, and this dot next will be initially will be null, because we don't know okay, where we are trying to insert this number. So our node is created, node 3 is created. Now first, sir, circular linked list 1. Again, this is a class circular linked list 1, and over here we need to create 2 3 things. First, we need to create head node 3 head, and with the circular linked list constructor, what we need to do, we need to make sure कि okay, head will be pointing out to null in the beginning, so that we know कि okay, there is no node stored into that head part right now. Now let's create a insert function. Int data. Now if we get a call for this insertion, what we need to check initially, 2 3 things. First, if head is equal to null, over here we need to create the node also, na? Node 3 n1, the new node, is equal to new node 3 and the data that we are receiving from the user. This way we create a n1 node that is storing the data that we want to store. Now after creating the node, we are searching the right position for that node. If head value is null, it means the list is empty. So what we will do, head will be directly pointing out to n1, and n1 dot next will be directly pointing out to head. So this is the scenario where there is only one node is there, right? In else, if there is no node right now and we need to find the last position where we want to insert, so what we will do, first we will create a temporary node also that will be initially putting out to the head. Now we are saying till the time temp dot next is not equal to head, because last node in circular linked list will always pointing out to the head, because this is circular linked list. So what we will need to do over here, we need to do till the time this loop is going on, so temp is equal to temp dot next. Till the time we'll go over there. The moment we will reach the last node, what we need to do after the last node, uh, temp, so we have reached to the last node where we need to do, so temp dot next will be pointing out, temp dot next will be pointing out to n1, and n1 dot next will be pointing out to head, right? So that's how we are going to insert the values. Insertion is completed. After that, we need to create one more function, a basic function to show the numbers. So in show, what we need to do, we need to run the same again, one temporary variable that will pointing out to head, and till the time while temp dot next is not equal to head, we need to traverse this list. Over here, what we need to do, system dot out dot print, and we will printing out the data of temporary, and we'll give a space over here, and temp is equal to temp dot next. If we'll reach over there, so the same, because the last temporary data will not be printed, so we'll be printing it out outside. This is done also. Now our both two classes is completed. We have created class for node, we have created a class for insertion and deletion that node. Now we will be taking the example, so where we will create the public static void main. So let's create class circular linked list 1 example. Let's create our public static void main over here, public static void main over here, and this will be our game. Now we'll create an object for circular linked list L1 that will be pointing out to, we have created the object L1, we are creating a new linked list. So linked list 1 L1 is first example where we need to insert few number, insert, and we will send out that data क्योंकि we'll insert 100 L1 dot insert 200 L1 dot insert maybe 10. So we are trying to insert 3 number, then we will call L1 dot show, we can see all the 3 numbers. So we will save this program. So there is no error. So 100, 210 we are able to print through show because we are printing into show only. Now if we are doing something like this, क्योंकि we are not putting out break to our head, right? So we are saying that till the time we are not finding null, this loop should go on. So this is a circular linked list, so there is a no null into a circular linked list means this loop will go on till infinite. So if we change the condition क्योंकि we are searching head into the last, right? But if you are searching null and in a circular linked list there is a no null, 1 is pointing out to 2, 2 is pointing out to 3, 3 will be pointing out to 1, means there is a cycle continuous going on, there is no null over here. So if we try to run a loop to find a null, so what will happen over there, this loop will go on, right? This loop will not going to be end over there, this loop will be continuously there, so we need to break it. That is why in this code what we are trying to do, we are trying to search head value कि okay, the moment I'll search कि okay which node is containing the value for the head, right? I know this will be the last. So out of 1, 2 and 3, what is the last node? 3. Why? Because 3 is containing the address for the first, not 2, not 1, only 3. So this is the basic idea of circular linked list, and that's how we insert and show our values into single circular linked list. Is it clear? So let's understand what is doubly linked list. Doubly linked list is a type of a data structure in which a node contains three things. One is data, one is a previous reference, and one is the next reference, right? The pointers also. So doubly linked list is a way to traverse a node or a linked list in a forward manner and backward manner. So you can traverse this linked list into bi-directional. If you want to go from 1 to 3, it can go, and you can also go from 3 to 1 also, because in previous normal linked list, single linked list, it was not possible. Why? Because there is only two things was available, one is data and one is next only. So only forward traversing or forward viewership was available only. But in doubly linked list, it was the idea where we store the reference for the next node also and the reference for the previous node also. So it can go bi-directional, right? So this is the basic idea of doubly linked list. So if you look at doubly linked list example like 1, 2, 3, so there is an first and last node. In first node there will be null pointer at the previous because there is nothing in previous, right? Same way the last node will contain in the next will be null. Why? Because there is a no node into next, right? So if you try to end a new value over there, if you look at it, okay, if we try to insert k, so it will go to the last, right? So 1, 2, 3, then k will be inserted in the last. Now if you look at the 3 will be pointing out to the k. So in the next of 3 will be stored the value of k, and the value of previous in the k will be stored the value of 3, so that it can traverse into both direction. Now if you want to traverse this node or linked list in a forward manner, what we will do? we will reach the head, or we will say ki okay, till the time the next is not null, it can go to the next part, right? So it will go over here, it will go to the one, the next is not null, so it will pick the value of next. So next will redirect us to the second, we will print second, then we will check again ki okay, the value of next is null or not. It is not null, then we will go to the third one, then again we will print this one, then we will look at the value null. It is not there, then it will go over there, then we will found the null, and it will stop over there ki okay, this is the last node in the linked list. Same way, if you want to traverse it into reverse formation, what we need to do, first we need to go to the end of the list, then we will start ki okay, till the time the previous is not null, till the time it will go okay, from this point ki okay, the previous is null, no it is not null, then it will go to the third one, third's previous is null, no it is not null, then it will go again back to the 2, then again it will check ki okay, the previous is null, no it is not null, then it will go to the 1, then once previous is null, then it will stop ki okay, this is the first node where we have started this whole double linked list. um, I hope the basic idea is clear ki okay, what is double linked list logic. We will understand this program into programming also. Is this idea clear?
Yes, sir.
Okay, so now what we need to do, let's look at the programming side. Okay, what we need to do in programming, in single linked list we used to create a node where we used to store only two data points, int data and node next. But in double linked list we need to store the third data point also, that is node previous. Now we will store three values in every node, right? So whenever we will create a node, what will happen, a node will be created, right? And there will be, this is the data where we store 1 2 3 or any other data, and this is the previous part, and this is the next part, this is the node itself, right? So now what we need to do, whenever the node constructor will be called, the data will be stored into the data, and previous and next both will be, next and previous both will be null initially when we will create a new node, right? So now we will show two things into this program. One, how to insert a new node into a linked list, and how to traverse this into forward manner and backward manner. So the inserting a node into a linked list is the similar as we used to do into a single linked list. What we need to do, okay, let's do it a dry run. Okay, we created the object for double linked list program, a class, and then we call the insert value 1, right? Insert at the end. So now we will go over there, this function will be called, and the data, the value 1 will be here, right? Now value 1 will be forwarded to node, new node is equal to new node, right? So this data will be go to the first class, right? In this class, and this constructor will be called whenever we will try to create an object. So this constructor, the 1 will be stored over here, and this first time a new node will be created, uh, you know the both side there will be null, and 1 will be stored into the data part. So 1 is stored into the data part, right? 1. Now what we'll do after this creation of the node, we will check it out ki okay, head is equal to null or not. So there is a whenever we create the double linked list, the first node will be inserted into the head. So till the time head is null, what it will do, it will point out to the new node now. So now our linked list has a one node, and head is directly pointing out to the that node only, and both previous and next is containing null value right now. Why? Because there is nothing previous and there is nothing forward. So 1 is the only node that is inserted into our linked list. So this is done till the time head null, head is null, what we will do, new node will be got the pointed out through head. Head has the position of new node now. Now this is the simplest part. Now whenever I try to insert another number, so insert at end is 2. Now little bit different. Why? Because head is not null. Head is already having a node right now. So now what will happen, a new node will be created, right? So this is like a new node will be created over here. So 2 will be stored. Now it will check you, okay, head is null or not. It is not null. Then what else, what it will do, it will do like node temp is equal to head. So we will create a new temporary pointer that will point out to the head. So initially this is the temp variable, temp also pointing out to the head node. Now it will check you, okay, till the time the value of next is null, it should go on, right? So in the first node the value of null is found over here, okay, the next value of first node is null. Then what it will do, if it is null, then it will, this loop will break, and it will say temp dot next is equal to new node. So what is temp dot next? So temp dot next is this variable, right? So this is the previous, this is the next. So temp dot next is this one. So what it will say, okay, temp dot next will pointing out to the new node. So this is our new node. So automatically this reference will be pointing out to our new node, right? And what it will do, new node dot previous is equal to temp. So this will pointing out to the temp. So temp is pointing out to this, so this will be pointing out to this node, right? And automatically this is storing the null value right now initially. uh, so the insertion of 2 is little bit clear, how we are trying to insert two number.
Yes, sir.
Okay, so now we'll try to insert one more number in this dry run. Third one, right? So third one will called, we will reach over here, right? Insert data, we will create a one more node also. So now we will create one more node also. In this node we will say inserted the 3, right? So again it will check ki, okay, head is null or not. Head is not null, so it is not going to worry. Then we will say ki, okay, temp should be pointing out to the head now until the time temp dot next is not equal to null. So is it null? No. Is it not null? So it will go to the next. So is it null? It is found null over here. So it will say ki, okay, we found the last node. So second is the last node into this linked list. So this null should be pointing out, means this temp will be pointing out to this. So temp dot next is equal to new node. So this null pointing will be removed, and this will be over here now. So null will be removed from this part, and this node will be pointing out to third one, and third previous will should be pointing out to the second one. And now there is a null is here. So this is the way how this linked list works. So what we need to do over here, again same, this this second node, and then there is a third node. This is how it will work. So 1 2, this will pointing out to this will pointing out to this, right? 3, this will store null, and there is a previous, so null is also here, and this will be pointing out through head, right? And the previous of this will be storing out the value of this, and the previous of this will be storing out the value of this, right? So that's how this double linked list will be created. Now there is a two method, print forward and print backward. Print forward will start from the head, and it will go on like till the time temp is not equal to null, right? Till the time temporary value is not null, it will go on to traverse into forward manner. So it will just go on like temp is equal to temp dot next, right? It will be automatically shifting to the next value, That's how it will going to traverse into forward manner. But when we are trying to print backward manner, what it will do, first it will traverse into forward manner. First it will reach, because we are already storing only one data point into our head, that is the first node. So we cannot go directly to the last node into this segment, right? So first we need to traverse it forward 1 2 3, then we will start it traverse it back ki, okay, 3 2 1. So we'll start printing the value of 3 2 and 1 over here. So now if we look at the, what to say, execution of this program, so double A linked list forward, double A linked list backward. So that's how this linked list got traversed into forward manner and backward manner. Is it clear? So now, what is circular double A linked list? So circular double A linked list is more complex data structure in which a node contains next reference also and previous reference also, right? And this is the only one of the linked list where no node contains null, right? There is no null in the whole list, right? And the last node contains the reference to the first, and first node previous will contain the reference of the last. So this is the way it will look like a circular double A linked list, or normally it will look like whole chain kind of thing that will circulate properly. So now if we look at the memory management, if you look at this memory management, because linked list not look like as an array in a system, so there are different memory locations. So now head is on the first address. So this is the data, and this is previous, and this is the next. So if we want to traverse into in a forward manner, means next. So if we will go on the next is on the 4. So we reach at the 4th location, there is a B, right? And B stores the previous is 1 and next is 6. So next is 6, then the previous is 4 and next is 8. 8 is D, right? And D is next is 6. Sorry, previous is 6 D's, and next is 1. So if we will go on the next, it will go again over here on the first. Then again if we will circulate it, it will go like this. Same, D's previous is 6, we can go on the 6. C's previous is 4, we can go on the 4. B's previous is 1, we can go on the 1. And 1 previous is 8, we can go on directly to the D. So we can traverse this list in a both manner completely, in a forward manner or in backward manner. Now there are 4-5 basic operations that we love to do on this linked list. One, inserting at the beginning, right? So if we are trying to insert a node at the beginning of this list, what we do? So if there is a new node that need to be inserted, and if this node was not here, this was the older link, let's do this. So if we look at first thing, when we'll start, if head is null, it means there is no node in the list. So we will, what we will say ki, okay, head will directly pointing out to a new node, right? And new node, if we are a new node is this, if head is directly pointing out to this, what we will do, the next of new node will also pointing out to the head, and the previous node will also pointing out to the head only if there is a first node in a list, right? And now if we are entering one more list to a new number, okay, if there is a one node, there is another node, and there is another node. Now we are entering a new node in the starting. So initially head was pointing out to this head, and again next previous, next, previous. This next will be pointing out to this, and this previous will be pointing out to this, right? Now if we need to insert one more new node, what we need to do first at the beginning? First we need to remove the old linkage, right? So we need to remove this and this. Now what we need to say ki okay, head will be stored into this next, right? So new node dot next will equal to the head, and head's previous, this previous will be pointing out to this, right? And the previous of this will be pointing out directly to this, and its previous will be pointing out to new node. And now we need to remove the head part also, and we can say ki okay, this head will be pointing out directly to the new node. So this will how it will look like, right? So in the same scenario, what we are trying to do, same thing, okay, we are breaking the old links between these two nodes and creating the new links. So initially head was pointing out to this one, but now head will be pointing out to our new node, right? And the next will be pointing out to this, and its previous will be pointing out to the new node, and last node will be pointing out to the new node, and new node previous will be pointing out to the last node. So that's how we are going to insert a new node in a at the beginning of a list. Same if we are creating an inserting at the last of the node, what we need to do again, we need to break their old link and create a new links, right? But we are entering this at the end of the list. That is why we don't need to change the head, because head is the same again, right? The same two scenarios again, where we need to delete a node from the beginning. So if we need to change the head also and change their links also. If we are deleting from the last, so we don't need to change the head, but we need to change their links of next and previous at all the locations. Logically you understood ki what we are trying to do over here? Can someone confirm?
Yes, sir.
Okay. So now I'll run a program first, then we will discuss. So we made a program of these 7 things: insert in the beginning, insert at the last, delete from the beginning, delete from the last, search, show and exit. So if we are trying to enter show right now, what it will say? List is empty, right? So we need to insert something first. So we are trying to insert something, so enter the element to insert at the beginning. 10. If we are inserting one more number at the beginning, means 20 will not be going to be head, 20 will be removed to the next location. So 20, then we again entered at the beginning 30. Now we are going to show the list. So 30, 20, 10, head is 30, then 20 is the next node, 10 is the last node, right? So now we are going to enter insert at the last. So now let's enter 40 at the last. Now we are going to show, okay, insert one more number at the last, 50. Now we are going to see. So 30, 20, 10, it is the same because we have inserted from the beginning. Now 40 and 50 was entered in the last. So this is the whole linked list that we have entered in the beginning, inserted into beginning also, at the last also. Now if you want to search, right? So let's search 100 or maybe 5. So if I am searching some number that is not in the list, it will tell me 5 is not present in the list. If I am searching 10, it will tell me 10 is present in the list. So I can search the number is present in the list or not. I can tell you. Now delete from the beginning and delete from the last. So if I am saying delete from the beginning, so what was the beginning right now? So 30, 20, 10, 40, 50, 30 is the beginning right now. So if I tell them to delete from the beginning, so deleted from the beginning. Now I can see what is the beginning. 20, 10, 40, 50. So 30 is gone. Now I can delete from the last. Fourth option is delete from the last. Deleted. Now if I'll see 20, 10, 40, 50 is also gone. That was the last node, right? And we tried inserting at the beginning, inserting at the last, deleting from the beginning, delete from the last, searching, show, right, multiple times. Now exit, and system.exit, we have done it. So this was the whole idea of this program ki we can try out these 5-6 functions of this doubly circular linked list. So now if we will start a doubly circular linked list, first what we need to create a node, right? This is a similar node that we create every time, right? In this node just there is one more pointer, previous is also there, next is also there. So this is doubly circular one, right? So in this constructor what we are saying is the number that is coming from the user, insert at the data part, and set previous and next is null initially, right? So that's how we create node. Now if we'll start a list, linked list. So after creating the node, let's start a linked list. So if we'll start a new linked list, let's create a head initially and put head on the null, right? So initially if list is empty, let's say head will be null. Now first part, insert at the beginning. If we are inserting at the beginning, there is first scenario, we are checking, let's create the new node first, then insert that data to that constructor, so that node data will be stored. Now first condition, let's check head is null or not. If head is null means list is empty and we are inserting the first node. So head will directly pointing out to new node, and head previous will be pointing out to head, and head next will be pointing out to head. So there is only one node that is pointing out to themselves, and this is the first node of a list, right? Else means if head is not null, means there is already few number or few node is present in the list. What we need to do now, we need to set new node dot next will is equal to head, means and please stay with me with this, and this will be little bit complicated for a little bit complicated if you will not focus. The new node of next, right? So new node dot next means this part will be pointing out to head, so this will be pointing out to head node, right? With this line we have set this link, so we need to set at least 4 to 5 link. Now new node dot previous will set out to head dot previous, so new node previous will be pointing out to head previous, so head previous will be last node. So we need to create one more channel to this node, okay, this previous will be pointing out to the last node. The third will be head dot previous dot next will be pointing out to new node. Now head dot previous dot next means head dot previous is this node and this is the next of this node. So this node will be pointing out to the new node now. Initially it was pointing out to the head, but this will pointing out to new node. So we have done this also, okay, the last node is pointing out to the new node. Now head dot previous will be is equal to new node. Now this node's previous will be pointing out to the new node, and now the last, we have set the 4 links. Now head will be pointing out to the new node. Now we are saying head to be okay, forget this, this is the new head now, and done. Inserting at the beginning. Is it clear what we done?
Yes, sir. Practice is needed.
Yeah, I'll share the program, but yeah, logically you understood now what we are trying to change here. Okay, now
Yes, sir.
great. So now insert at the end. If we are inserting at the end, this program is same. It's very simple and very same. You have to remember 3-4 logical links only. First we created the new node. Again we are checking head is null or not. If head is null, we understood ki okay, there is no, list is empty already, so we have entered head, new node to the head, and same head dot previous and head dot next will be pointing out to head also. So this is the first node of this list. Now if we are entering in the last and we are knowing ki okay, it is already not null, means there is already few nodes are there. So new node dot previous will be pointing out to head dot previous, means if we are inserting at the end, right? So what we are saying ki, we are saying new node dot previous will be pointing out to head dot previous. So initially the link was from this to this, now this link will be directly pointing out to this one, and new dot next will be pointing out to head, new node next will be pointing out to head, and third head dot previous dot next will be pointing out to the new node, head dot previous dot next. So head dot previous was this, and the next is this, so this will be pointing out to the new node, and the last is head dot previous will be pointing out to the new node. So head is this, head previous is this, will be pointing out to the new node. That's how a new node is entered. We need to alter 4 references, and because we are entering in the end, we don't need to change the head. That is why there is no need to change the head. Over here we have said because it is in the beginning, so head will be pointing out to the new node in the end, but in this scenario it is not required. We just need to change the 4 link. Same it is done if we will delete. We are deleting some number, so first we need to check the list is null or not. If list is head is null, means list is empty, nothing to delete and return. ठीक है. Second scenario कि if head dot next is equal to head, it means there is only one node, right? If head dot next is pointing out to head, it means there is only one node available in the list, and then what to do? Head will be null. So if I'll tell you the same, if there is a scenario where there is a one node available, and this is the head, and if this is pointing out to this and this is pointing out to this only, it means there is only one node. So what we need to say कि okay, if there is one node available, just say head will be equal to null. Now done, the link is broken, list is empty now. So this is the second scenario. Now the third scenario where we know कि okay, there are multiple nodes, not one, more than one node is available. So what we need to do, if we are deleting from the beginning, head dot next dot previous is equal to head dot previous. So if we are deleting from the beginning, what we need to set? Head dot next dot previous. So head dot next dot previous. So the previous of this, right, the previous of next will be head dot previous. So previous of this will be setting out to this, right? So initially this link was from here to here, copy this link to this. So now we will be putting a new link from this to this node. Second, head dot previous dot next. So head dot previous is this, and the next of this, so next will be pointing out to this only, head dot next, right? So initially head dot next was this, so this will be pointing out to this node directly, and head will be pointing out to head dot next. So head will be now pointing out to the next node. So this node link is broken and this is out of our list. Same if we delete from the end, first scenario, if list is null, head is equal to null, means list is null, there is nothing to delete. Second option, if there is only one node available, then directly set head is equal to null and done. Third scenario where we are deleting from the end. So if we are deleting from the end, what we need to do? First scenario, head dot previous next. So head previous, right, next means this will directly pointing out to the head. So head previous next will be pointing out to the head, and head dot previous will be pointing out directly to the head previous, right? So previous is previous will be pointing out from this point, and the whole connection is broken and done. You are deleted, right? So now if we will try to search something, first we will check okay, list is null or not. If list is null, head is null, means list is not there. So we can tell them that nothing to search. And if you are searching, so put a new pointer on the head, that is current. Now we can shift current to the next. So if current dot data is equal to key, it will say return true. Else what we will do, current will be current dot next. So it will be moving to the next node every time, and we will use do while loop. Why? Because in the last we will check if current is not equal to head. So if we are checking from current to next till the time it will not equal to the head, means in the circular it will again reach to the head. Till the time loop will be go on, and we will searching all the data element of the current. So if it is not available in the whole list, in the last it will return false. Otherwise if it will match, it will return true. The last part is show, traversing of the whole list. So node current will be head. First we will check okay, if list is empty, tell them list is empty. Otherwise node current will be on the head, and print current dot data, and current will be on the current dot next. Till the time current will not equal to the head. The moment it will get equal to the head, means the whole list is traversed, and we have again reached in the starting from the circular linked list. So in the last, when current will be equal to the head, it will break, right, and printing will be done. And the menu will be created through while loop. It is simple, and we can use switch cases where whatever they enter 1 2 3 4 5 6, we can call the functions. So if they are entering in the beginning, take the data, then call the insert at beginning function. So they want a second part, insert and the end function, right? Same, delete from the beginning, delete from the end, right? And the use same object, object is the same. If you will look at this program, we have created the object of doubly circular linked list. One means we are creating one list only, and using all the functions according to what user is telling us on the basis of their input. So delete from the end, search the data, if data is present, print present, otherwise say not present. 6, the list elements are list dot show, means traverse the whole list and print the data, and last system dot exit on the 7th case. So yeah, this is the whole scenario. Now if we will execute this program one more time, we can understand okay, what is going on. So these 7 options we are showing them. So if they need to insert, first insert, so 10, insert 20, insert 30, insert 40, insert 50. So now after inserting 5 elements from the beginning, if you want to see, 50 is the head node, 50, 40, 30, 20, 10. Now let's enter 4 5 numbers from the end. Insert 60, insert 70, insert 80. Now we will see 50, 40, 30, 20, 10, 60, 70, 80. So these 3 nodes are entered from the last now. Now delete from the beginning and delete from the end. Third, if we deleted 2 nodes from the beginning, now we will show. So 50 and 40 is gone. Now 30, 20, 10. Let's delete 1 node from the end, 4th, and 80 will be gone, right? 30, 20, 10, 60, 70, 80 is gone, right? So we have deleted from the beginning, deleted from the last. And if you want to search some number, you can use 5th. Now if we are searching the 80 or something, it is not available, right? So if we are searching 30, it is available, 30 is present in the list, or we are using 6th choice to print the whole list. So this is the whole idea of this program, to show you how to insert at the beginning, insert at the last, delete from the beginning, delete from the last, searching and showing the whole list, and at 7 number it is exiting. Yeah, so Is it clear, everyone? Completed the insertion and the traversal part in single linked list, single circular linked list. So today we'll try to delete a few number from a circular linked list, because it is hard to delete a number in a linked list than an array. It was so easy into an array, okay, we will just give the index number and we can delete the number, right? But in linked list we have to do a lot of things to delete a number. So first understand there will be a 2 3 scenarios. One, the list is empty, then we have to give them ki, okay, list is already empty, there is no need to you know uh, delete a number in this list. Second, if list contain only a single node, then what to do? Third scenario, when list contain more than one node, then what to do? There are three scenarios in single circular linked list to delete a number. Now we will first discuss the last scenario कि okay, if there are multiple node in a linked list, then what to do. So if you look at there will be a so there is data and there is next. So data will be something like 10, 20, 30, 40, right? And they all will be pointing out to the next, 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 and the last will be always pointing out to the first one, right? And the head will be pointing out to the first node in a singular circular linked list. Now there will be a three scenarios that what we need to delete. First scenario will be we found the data that I want to delete, or we want to delete on the first node or a head node, right? In scenario means head dot data is equal to data, then what to do, right? So what we can do over here, this will be the easiest scenario. uh, we will say कि okay, we will pointing out directly head to this one. Now if it was not a circular linked list, it was more easier. So we will break this head connection with this node, right? And what we need to do now in the last node, क्योंकि the last node that is going to till the head, we will say कि okay, you can directly pointing out to this, and we can break this connection also. So if we break this connection and this connection, this node will be out of our linked list. So this is the first way or first scenario. Second scenario will be कि okay, we will find our node into somewhere in between, right? कि okay, uh, you know let's say we will not going to do this, or we will not going to do this, or we will not going to do this. So head is again here, and now we want to delete 20 or 30, right? Some a number that is already in a list or in between multiple nodes. So if I'll say कि, okay, I want to delete 20 or 30, like say we'll delete 30. So what we will do, simple, we will run two temporary variables that will be go into the current node and the previous node also. Now we just have to do one thing कि, okay, the reference will be directly shifting it to this, and we will break this connection, right? It means this 30 is no longer into the linked list now. This is the second scenario. And the third scenario will be what? If we want to delete the last node, then what we need to do? If 20 will be there, we want to delete 41. So same scenario, we take two numbers, temporary and temporary one. We will traverse this list and we will reach out कि okay, we will need to delete 41. So we just need to create कि okay, we will break this connection, and from this point we will say कि okay, this will directly pointing out to head node. So our circular linked list will be 10, 20 and 30, and it will circulate like this only, and 40 is out of our list. So is this logic clear little bit? कि okay, logically got it कि okay, what we need to do, we will create a program to explain this. uh, so yesterday we created this. So let's delete this function. So we inserted and we created a show function to show our list. Now creating a delete function. Now delete function, what delete will do? Let's look at void delete. In delete, a user can send data from public static void main. And now we will look at the three scenarios that we were discussing. First, create a temporary nodes also, node 3, temp is equal to head. They both initially will pointing out to our head part. 3, temp 1 is equal to head, right? Now the first scenario is if list is empty, right, then we can directly return it back ki, okay, list is already empty, means head is equal to null. It means we will tell them ki, okay, system out dot println no node in list, there is no node over there, right? Now if we look at the multiple scenarios, like if we found our data on the head itself, then what we need to do, head dot data is equal to data. If we found our data on the first node, what we need to do, we need to make sure ki, okay, we need remove the reference from the last node, so that this data will not be going to be on 10th. We will fix ki, okay, the last node will contain the reference for the 20th, the next node. Now what we will do over here, we need to run a loop to till the time temp dot next not equal to head. And this situation will be only false, right, when this list will reach in the end. Only last node contains in the next the reference for the head only. They all don't contain. 20 is not containing the reference for head, 30 is not containing reference for head, only 40 means last node will always contain reference for the head in circular linked list. So this loop will go on till end. Then what we need to do, temp is equal to temp dot next to reach the last. In the last, what we need to do, we will say ki, okay, head is equal to will be head dot next, means we are shifting head from here to here, right? And now we are saying ki temporary dot next will be directly shifting to the new head. I think this is done for the first scenario. Now we'll look at the another scenarios. In another scenarios, we will say ki, okay, if we are not going to find the value on the first node, what we need to do, first we will shift temp is equal to temp dot next, then we will run the loop ki, okay, till the time we will not going to reach in the last. What we need to do over here, first, if temp dot data is equal to data, till the time we don't find our number to delete, what we need to do over here, temp is equal to temp dot next, and we will make sure temporary one will be reaching out to temp now. If this will go on, okay, so these two will not be into if condition. If this will be true, these two will come outside the loop. If this will be true, because we found our data, we just need to do one thing, temp one dot next will be pointing out to temp dot next, because temps next will be shifting to our temp next. Now in this scenario, if this loop will be go on and this loop will be reaching out in the end, what we need to do in the end, the same thing that we are doing over here. If we found our data in the last node, temp dot data is equal to data, what we need to do over here, we are just saying the same thing again, okay, temp1 is equal to temp sorry, temp1 dot next will be storing the data for the head, and we are done. I think this will work. So we are trying to delete few numbers initially, and then we are calling the show. So compiled without error Java. So initially the list was 100, 200, 10, 500, 150. Then we print the show, then we called the delete 500, and 500 is removed from our list. Then we can check, okay, if first number is getting deleted, compiled and run. The 100 is removed from the list. Or we can check in between number. So now 10 is removed from the list, right? And same, we can delete multiple numbers. So we can delete 500 also. So 10 and 500 both are removed from our list. So specifically in circular linked list, if you really want to check it out ki okay, this is working, this is the best way. Why? Because circular linked list will go on till the time they are not finding head, or the whole circle will be completed, right? So is it clear?
like uh, सर जैसे बुक्स बुक्स का एक जैसे टेबल के
Stack,
ऊपर सर बुक्स हैं,
right?
बुक्स के ऊपर बुक्स रखी हुई हैं, तो वो सर स्टैक में है।
Exactly. Right. So
या
stack is a data structure, linear data structure that follows LIFO, last in, first out. So you
या
have
सर लास्ट
right. So you have given the right example. कि okay, the stack of books on a table or a stack of newspaper, right? So normally, as in Indian, what we do? Normally we stack the newspaper at a place to sell into the kawadi wala kind of thing, right? So
या
on top of, if I'll try to pick a newspaper from that stack, you will find the latest newspaper on the top, right? So
सर
because stack has one end, only top. So stack only enters or deletes through top only, right? And real world examples are again books and newspapers. So what kind of stack LIFO it follows? So if I try to push a number, so first number will go in the here. If I try to push another number, it will go over here. Another number, it will go on the top only. So we can see कि okay, the first number that we entered in the bottom now, and in the top is the last number that we entered. क्योंकि fifth number is the number that we entered in the last, right? So automatically what will happen, whenever we try to pop these number, or take outside of these number, top will always come first, right? So the last in, first out means whatever is entered in the last will get out first, right?
या
So, there are some common operations that we implement on stack. One is push, one is pop. Push is for inserting an element, pop is for
इंसर्ट
deleting an
पॉप
element,
मींस डिलीटिंग।
right? So, is empty to check stack is empty or not. Is full is for checking is it full or not. Peek to return the top element. Count to check the total number of element in a stack. Change and display, change the element given position or display to display all the number. But yeah, majorly we will perform four major operation: push, pop, is empty, is full, or peak. These four or five operations are the major operations. So how we do the push operation? So before inserting an element in stack, we check whether the stack is full or not. So whenever we try to enter a number, right, so we need to check okay, stack is full or not. If we try to insert an element in the stack and the stack is full, then the overflow condition occur. Means if there are five number we can store and we have already entered the five numbers, after we will try to enter one more number, it will show us overflow state. Okay, it is already full, we can't enter more number, right? uh, we will initialize stack initially with -1 to check stack is empty or not. Or whenever the new element will be entered, it will be go the top will be go as a top is equal to top plus 1 or top plus plus, right? The element will be inserted until we reach the maximum size of the stack. We can enter the maximum number till the time we will reach in the you know maximum size of the stack. So initially if stack is empty, top will be -1. When we enter 10, so we will do what, we will increase top by 1. So top is now 0 and we entered the number over here. Now top is 1, we entered one more number. Now we will again increase the top with the 1. Then we entered the push 30 and we increased the top to the 2. We inserted 40 and top is now 4. Now stack is full. So whenever we will reach, so the top value will be 3. Now if we will try to remove it, it will be removed from the top only because it is last in first out. So if top is 3 and the 40, so we will pop out 40 and we will minus the top, so we will reduce top by -1, right? After that we will try to do it one more time. We will remove 30 and we will reduce with -1. Now we will try to remove 20, pop 20 and we will reduce top by 1, right? And after removing 10, we will reduce top to the -1. -1 means now stack is empty, right? So now if we try to
Yes.
pop one more thing, it will say as underflow, means stack is already emptied and there is no more number to delete, right? So that is the two major operation, push and pop. Logically, is it clear?
Yeah, sir.
Okay. Let's now make a program out of it. So there are two ways. There is two ways to implement an stack. One is through array and one is through linked list. Right. So we will try to complete today only array. If you have any issue with the linked list, you can ask. Otherwise, try to do it yourself through linked list. So I'll explain you through array. What we do, we will create a stack class and 2 3 variables. One variable is our array, one is top and one is the maximum size, right? Or initially we set this size whatever the you know whenever we will create the object, user will give us, we will put it this into a size. Through that size we will create the array of that size and we will set top with -1 so that we know ki okay, right now stack is empty. Now we created a push operation, push function, a pop function, a peek function, is empty function and is full function, right? And in public static void main we are starting this game, right? So first we
Yeah.
created the object of the class,
Object create.
yeah, with the 5 size. So the 5 size will be the size of array now. So now we are trying to push 3 number, 10 20 30, right? So push function will be called
Yeah.
in first time whenever we try to enter 10. So in the push function what will happen, the number will come over here in the as a parameter, whatever we are trying to enter 10 first time. So it will check first ki the list is full or not, stack is full or not, is full. How it is checking is full, is going to call this function called is full, right? So is full is checking top is equal to maximum size -1. It is checking ki okay, if array is in the top is reached the location of 3 or maybe 4 right now, because over here our size is 5. So if top is 4, it means the array is full already, we can't enter more number, so it will return ki okay it is full. So if it is checking ki is full and it is true, so it will tell us ki okay stack is full, cannot push. Else it will increase top by plus plus. So now top value will be 0 because initially it was -1, it is 0 now. Stack array on the top, so now we are passing this through this. So on the 0th position of this array we will be storing the new value, means 10 is stored on stack array 0, and we are giving printout to the user ki pushed value onto the struct. Now we will do it for the 20, now we will do it same for the 30 also, right? After that we are picking it ki okay what is the top number first. Before again checking for the top number, it will check is stack is empty or not. Empty means if top value will be -1, it means stack is empty, right? uh, or otherwise it will give you the top value of that stack. Now we are popping out the numbers, we are using pop. So we have pushed three numbers over here and trying to pop four numbers. So in the fourth time it will tell us ki okay the stack is already empty. So when we are going to use pop method, first we will check ki is empty or not, means stack is completely empty or not. If it is empty it will tell us कि okay stack is empty, cannot pop, and return -1. Else what it will do, store the top value into an temporary array or popped value, and do minus minus for the top, so that top will be minus. If it is 3 it will go to 2, if it is 2 it will go to the 1. So it can reduce itself from the 1 and tell the user कि okay we have popped the value from the stack, and return popped value whatever we have popped, right? And again peak and is full or is empty. Now it is done. Now we will just try to compile it and run it. So it is compiled. Now we will try to run it. So let's look at it like this. So just look at it like okay. So so now we push 10 onto the stack, then we push 20 onto the stack, push 30 on the stack. Now we are using peak. Peak means it will return us the top value. So top element of the stack is 30. Why? Because if we are entering 10, 20, 30, so 10 will be on the bottom, 20 on the top, then on the toppest number will be 30. So now we are
Yeah, yeah, sir.
popping out popped 30 from the stack. After removing 30 we are again using peak. So now top element is 20, then we again popped, then 20 is popped from the stack, then we popped 10, 10 is also popped. Now we are using pop one more time, so it will telling us stack is empty, cannot pop, right? So now we can push two more numbers because it's 5. So stack dot push, we can 50 push, right? And stack dot push 100 also. So we can do this also, and we can again compile it. This time stack will not be empty because we are pushing 5 number and popping out only 4 number,
Yeah, sir.
right? So we have pushed 10, 20, 30, 50, 100 also. Top element is 100, then we have popped 100. Now the top element is 50, we popped 50, 30, 20. Now only 10 is left in that array, right, in that stack. So that is
Yeah.
how we implement stack through array. You can use it through linked list also, the same thing. You always put the head only on the top value, क्योंकि whatever we are inserting through head only, right? So is it clear, bro?
Yes, sir.
Okay. So is there any query regarding this? So now we will start the tree data structure. In all the data structure that we have studied till now, tree data structure is known as the hierarchical data structure. Why hierarchical data structure? Because till now, whatever we are studying, trying to do with these things, ठीक है, they all were linear data structure. If you were studying array, so array is a linear data structure where you can uh, store data in a linear format, right? But tree representation will be into hierarchies, so hierarchies of family, hierarchies of corporates, right? So if you look at this one, so John is the kind of main manager. Over there two sub manager, or their reportees, that is Steve and Rohan. In Steve there are three people working. In Rohan team there are 1 2 3 4 5 people are working. In Sal there is no one working. Emma, three is working, right? So that is the representation that tree data structure provides us, hierarchical way, where you can show into multiple levels, right? Again, this will be a lot of new words that we will use, terminology that we will use, but yeah, it will be similar to normal tree. So in tree normally there is a root, so same way in this tree structure, John is the root structure, right? So a tree data structure is defined as a collection of object or entities known as nodes. सो हर सर्कल को या हर उसको अपन नोड बोलेंगे जब, सो सॉरी, सो ईच सर्कल वी विल कॉल इट अ नोड. Why? Because this will be same as a linked list node that we use to create. A tree data structure is a non-linear data structure because it does not store in a sequential manner. It is a hierarchical structure, as a element in a tree are arranged in multiple levels. Again, it is a hierarchical structure where nodes are stored into multiple levels. In the tree data structure, the topmost node is known as the root node. So this is our root node, right? So in each and every tree, the first node will always be known as the root node, right? And others will be their children. Each node contains some data, and other nodes they can data and links. So these are the terminology. I'll explain it, but slowly, gradually, we will use it in everyday scenario. So first root node, then child node. So everyone is child of the root node. Parent, in like in this scenario, like this one is parent for the 2 and 3. Uh, you know Same, 5 is the parent for 9 and 10. 4 is parent of no one, right? So child node, parent. So in each node we can understand कि okay, the next successor will be their child node and this will be the parent node. Like 11 is the child node of 7 and 7 is the parent node of 11, but 7 is the child node of 3 and 3 is the parent node of 7, right? uh, sibling Sibling is like if their parents are the same, right? So 2 and 3 their parents is 1, they are the sibling. 9 and 10 their parents are the same, they are the sibling. In real life we call siblings in the same way we use it over here, right? Leaf node leaf node are the node that doesn't have any child. So in this thing, in this tree, 4 is the leaf node, 9 is a root node, 10 is a root node, 11 is a root node, sorry, leaf node, 6 is the leaf node, and 8 is the leaf node. So any node that doesn't have even a single child, no left, no right, then it is a leaf node. Because in a tree, leaf is the last part, or maybe the highest part of a tree, right? After that it will not succeed or success more. So internal node, a node has at least one child known as the internal node. So other than leaf node, all are the internal nodes. Ancestor node, so ancestor node is the predecessor. So if you look at the who is the ancestor of the 4, so immediate is 2, then more, the ancestor of 2 is 1. So 2 and 1 is both is the ancestor of the 4. Same descendant node. So the next immediate node, the next child will be known as the descendant. So descendant of 1 will be 2 and 3. So they both are the descendant of 1. Uh, I hope these terminology I am able to explain you. If you have any question regarding any terminology, you can ask me anytime. Now we are just discussing today कि okay, what is this logically. We will try to create a basic program also today. I'll show you today one program at least. uh, so properties of tree data structure. uh, Recursive data structure. Recursive in a sense, we used to create recursive function initially when we used to do a lot of factorials and palindrome things, right? So the tree is known as the recursive data structure. A tree can be defined as a recursively because distinguished node in a tree data structure is known as the root node. Why it is a recursive data structure? Okay, so why it is a recursive data structure? So one is the root node for whole tree, right? But the moment it will be divided into subtrees, like it is the left subtree, it is the right subtree. In left subtree, if you look at, 2 is the root of this subtree, right? Then 2 will be divided into 3 parts: left subtree, right subtree, right? If you look at it, 4 is the leaf node, right? 5 is the root node for 9 and 10 for their subtree, and 6 is the last node. Same way, 3 is the root node for the 7 and 8, right? So in each subtree, each node is treated as their root node, right? Even the 4, 9, 10 will also be treated as a root node because they don't have a child, but yeah, they have a null reference. So everyone is storing the value of null. So recursion means reducing something in a similar manner. So the recursive property of tree data structure is implemented in various applications. So number of edges, how many, if there are n nodes, then there will be n minus 1 edges. Uh, each arrow in the structure represent the link to the path. Each node except the root node will have at least one incoming link known as the edge. Depth of a node. So depth of a tree will be decided on the basis of the root. So root node is on the 0 depth. So these are on the first depth, these are on the second depth, and these are on the third depth. So this is how you calculate the depth of a node. Okay, what is their distance from the tree? So if I'll check the depth of the 7's depth is 0, 1, 2. So 2 is the depth of the 7th node. So the height of a node can be defined as the longest path from the node X to the leaf node. So same, if you calculate depth, height will be calculated from the one only. Okay, what is their starting point? Now how to implement a tree? The node contains 3 fields in programming world. The middle field will be the data part. The first field will be the left reference to the left child. The third field will be the reference to the right child. So that's how it will look like. Now if you look at tree data structure, it will be multiple types. I think 4 or 5 trees are available right now. So first tree is the general tree. So general tree is one of the type of tree data structure. A node can have either 0 or maximum n number of nodes. Means they can have multiple child or 0 child. So like C, D, E, G, H, leaf node don't have any child, but B has 3 child, right? F has 2 child, J has 4 child, M has 2 child, right? So they can have 0 to n number of child, right? There is no restriction imposed on the degree of the node, the number of nodes that can a node contain. The topmost node in a general tree known as the root node. So every first node in every tree will be known as the root node. The children of the parent nodes are known as a subtree. So that's a general tree. right? So 0 to n number of nodes can be a child, and there is no restrictions, right? Okay, who can have how many kids or child. So now binary tree comes second number. So binary tree is like an India's scheme initially in I think 90s. कि वो if you have read that campaign हम दो हमारे दो, right? So it puts restrictions on each node to have maximum two child, right? So in binary tree, if you look at, there can be only zero child, one child, or maximum two child. You can't have more than two child. So over here, if you look at it, 8 has two child, 3 has two child, 6 has two child, 10 has one child, 14 has one child. So every node can have maximum two child, not more than two. Then there will be one more tree will come, binary search tree. It will follow the binary tree, don't worry. After that, multiple trees followed this pattern only. And the third or fourth one will be AVL tree. So AVL tree we will explain you later. It will take time. First we will do binary tree, then we will do binary search tree, then we will do AVL tree. So every tree will take your time, 30 minutes or 1 hour every day, right? So what is AVL tree? AVL tree is a self-balancing tree. So it follows the rule of binary tree and binary search tree, and it was invented by Adelson Welsky Lindas, right? So that is why it is known as the AVL tree. That is the name of the in who invented this tree. We will explain you AVL tree properly because it is little bit more tougher than normal tree. So now first let's discuss our binary tree that we want to discuss. So the binary tree means that a node can have maximum two child. Like one has a two child, three child. Now if you look at the logical representation will look like this only, right? So there will be a root node. ठीक है, they all are nodes. So they have data, they have the left, they have the right reference. So they will be storing the value for this node, and these node will be storing the reference to these nodes. So that how your binary tree will look like logically. Now there are 3 to 4 things more that we need to discuss, but yeah, we will discuss it when we will run a program first. So there are pre-order traversal, in-order traversal, or post-order traversal. Traversal is like how you are going to visit each node into a tree, how you are going to traverse a tree. That is known as the traversal. So we'll explain this. Oh. Now, if you look at it, I hope it is clear till now. So can somebody confirm me? Matlab, I am going. I hope I am not going too fast. Okay. So if I am going too fast, you can tell me. Na? Matlab, we can take 5 to 10 minutes more on any topic. No issues over there. So now let's move to one example that I want to show you. After that, we'll explain you one thing. Then we'll try to do more program. So I'll show you a program. Where is the program? This is the program. I'll share it with you. But yeah, tomorrow we will try to do it ourselves also because it is a lengthy program. So I don't want to waste today's time. So it's just a program, and how it works I'll explain you later. But let's look at how it runs, right? So let's run this program. So this program is like will ask you few things. If you want to exit, you can press 0. If you want to enter a new node, you can press 1. So I'm telling them okay, enter a new node. So I am saying enter your choice 1. Now data, so I am entering 100. So 100 will be the root node. So let's also create the that part also. So 100 is the root node. So now it is asking enter the left child of 100, press 0 to exit. So I am saying I want to enter a left child of 100. Let's say I am entering 10. So 10 is the left child of 100 now. Now it is asking me कि okay enter the left child for 10. I'll say okay, let's enter 5. So 5 become the left child of 10. Now it is asking me enter the left child for 5. I am saying no, 5 will be the last node. So exit. Now it will asking me enter the right child for 5. So it is saying asking me first left child, I said no. In right child I'll say again no. Now it will check me enter the right child of 10. Now it is asking me enter a right child for 10. So let's say enter the 20. So now I have entered 20 over here. So now it is asking me okay, tell me the left child for 20 or right child for 20 now. I'll say no. I'll say no. Right. Now it is asking me enter the right child of 100. Now right child of 100. Right. So 100 right child I'll say let's enter 200. Now it is ask me enter the left child for 200, then it will ask me enter their left child or right child. So now I'll say ki okay, let's enter 50 and I'll say 0. 50 is right child 0, and now I'm saying ki okay, I don't want to do it. Now 0 to right child, 200's right, I'm saying no child required into 200. So over there I said 50, right? So there is no child for 200, right? Exited. Now I am showing in order traversal, pre order traversal, post order traversal. So what is pre-order traversal? How you are going to visit each node? So this is the sequence of their how we are going to read the node. In pre-order traversal, root left or then right. In order traversal, left, root, right. In post order, left, right, root. So let's discuss pre-order traversal. In pre-order, root will come before everyone. So if you look at this, now I am going to traverse this node and then we will check with the output कि we are telling them right or wrong. So this is the root. So first we will go to the root, print root. Then it is saying pre-order left subtree. So the moment I'll go to the left subtree, 10 become the root node for this subtree. So I'm printing 10. Then 10th left subtree, root left. So we will after root we will go to the left. 5 will be the last node. Then 10th right node 20. After completion this मतलब 100's left subtree is completed. Now we will go to this 200 become the root node and 50 is their left subtree. So if our output of this pre-order is same, like if you look at the pre-order part, 100, 10, 5, so 100, 10, 5, 20, 250, right? So we are going to predict our pre-order traversal perfectly. Okay, this is how we will do the pre-order. Same, if you look at the in order traversal or post order traversal, we will do it to both also. So in order traversal, left, root, right, right. So in order, first, like if we will try to do it, right. So in order, what will happen? What say left, root, right. So first we will reach directly to the 5. Left, then root means 10, then right means 20, then left subtree completed, then root, that is 100, then right, then left means 50, and I think then 200. So that is our in order traversal. Let's check with that also. So 5, 10, 20, 100, 50, 200. So in order traversal is same that what we are trying to do. Can somebody predict me the post order traversal? Unmute yourself and tell me what will be the post order for this tree. Ashish, Raja.
Sir, 5 and 20.
Okay, 5, 20. Okay, right. Initially you are right. After that 520, it will be 10 because 10 is the root of 520. Then we will go to the right part and the left part. Then uh, you know 50 and okay, left, right 200, and I think last one will be 100. The root, right? So if you check confirm the while also I think yeah. So 5, 20, 10, 50, 200, 100, right? So first I'll went to the left node, then right node, then this root node. Their subtree is root node. After that, if I'll reach over there, it is again left node, then any right node, then their root node. When left subtree complete, right subtree complete, then the root node will come. I hope the traversal is clear, matlab.
Yes, sir.
Okay, so we will stop it over here only today. So if you have any query, you can ask. We will try to cover it up. Child or every what to say root has a two child only, two child policy only, right? So हम दो हमारे दो. Same way, every root or every node has only maximum two child. So 0, 1 or 2, right? They can have that much only. And there are four kind of traversal: in order, pre-order, post-order. It is a typing mistake over here. So in order is left root right, pre-order is root left right, and post-order is left right root. So that's how we traverse the tree. Now I'll explain you the whole program, how to make this program in a better way. So initially we need to create a class of node. Whenever we are creating a basic binary tree, so there will be three data. One is int data, that for storing the data. Second is node left for left reference, node right for right child reference, and the constructor where we will take the data, and total node this dot data is equal to data, and left is equal to null, right is equal to null. So that's how we create first node or one node at a time. Now let's create a binary, one more class, binary tree test. So we will going to create our binary tree over here. Now in creating a binary tree, we will create in this program four functions: one to create or insert a node, and three functions for different traversal: pre-order, in order, and post-order traversal. Okay, how we are going to traverse the tree. Now uh, initially let's create node insert. And because we are thinking to take data from the user, to do the import also, import dot util dot scanner class. In this insert, first create an object of scanner. Sc is equal to new scanner system dot in. Now after creating this, we need data part also, and data is there, done. And then create one more thing, that is node temp, because our return type is node over here. Now if whatever data user enters, now I'll tell the user also to enter the data, enter data, and user will like enter the data. Data is equal to sc dot next int. So when user enter the data, data will be stored over there. But if you understand the property of a tree, so tree is a recursive functionality. So when we are using recursion functions, so there should be a point where we should stop the recursion also, na? So in that scenario, what we do, we are saying कि okay, if Data, if user enter data as a -1, right, then we should end the recursion, return null only. Else what we can do, we can in else what we will do, first we will create our temp is equal to new node and transfer the data into that constructor only. Now we need to call recursion for the left subtree and right subtree. So what we will do, we will tell user to enter, and we are entering this as a pre-order insertion only. Enter data for left of the data, print data over here, and let's say done. Right, now call the same function recursion. We will start the recursion same function for the left part. Temp dot left is equal to insert, right. Then we will do the same thing for the right also. So over here enter the data for the right of same data and temp dot right. So when you call the recursion for the left and right both, now return temp only. So this temp will be returned as a root node at our insertion point. So let's, it is closed. So this else is closed, then this function is closed. Now we will create those traversal functions. So void traversal for pre-order node root. So we will transfer that root as a parameter over here. Now first condition in every traversal, we will check only कि if root, till the time root is not null, we will go on, right. And because it is pre-traversal, so what we will say, okay, let's remove it, system out dot print the data of the root. In pre-order traversal, we will traverse as a pre-order means this order is decided on the basis of root. So root left right is pre-order. So we will print the root data, and then after that we will start the recursion. So recursion for the same pre-order root dot left and then pre-order root dot right, and we are done. So that's how we traverse. So void pre-order, then let's create one more function, two more function basically. So void in order same root is transferred over there. When root is there, so if till the time root is not is equal to null, we will traverse this data. And in order is means root will come in between left and right. So left root right. So in that scenario, what we will do, we will call first recursion, left recursion first. So root dot left and system, we will use the same system out dot print over here because it's need root will be printed in between. Then in order will be called for the root dot right. Same function recursion will happen. The third recursive function is in post order, and we will pass the same root node over here. And in post order, what we will do, left right root. So if root till the time is not equal to null. What we will do first, we will call post order for root dot left and post order root dot right, and then we will use to print this data system out dot print root dot data, and we are done. So now we have created four functionalities over here. Now we will create our public static void main. So over here, let's create the object of binary tree example or binary tree test. What class we have created over here? Binary tree test. Let's create the basic object of is t is equal to new. Now first we will call the insert function for the tree. Now the t function, the insert function we have created as a where return type of insert is node. So this temporary node will be returned as a root node after completion of insert. So we should hold it into this root. Node root is equal to t dot insert. Now we are going to call three traversal t dot pre-order, t dot in order and t dot post order, and it is parameterized function है ना, so we will pass root in all the functions. And because over in function we are using system out dot print only, so because it will not create hodgepodge, so we will be entering this println. And let's save it. I think it is done. So let's save it as a binary.
Sir, curly braces
Which curly braces?
at last term.
It
There
is,
were should be two.
yeah, it is there. Don't worry, I'll show you. Binary tree test. The curly braces are there, but it is so below the space that you are not able to. So this is the curly space. Basically, in coding, I normally code on maximum code. If you are saying I'll code on Notepad, so whenever I'll create one open curly braces, I try to close also same time. Otherwise, it will create hodgepodge. In maybe VS Code or maybe what to say, NetBeans and Eclipse or IntelliJ, you will find it very easy to operate. But yeah, in Notepad, you have to call it in the right way. Otherwise, it is not forgiving you. The same. Again, there will be error because again some semicolon, some spelling mistakes. But it's good to solve errors, I think. Okay, so it is compiled without error. So binary tree test. So enter data. Let's create one more thing over here. The same time we will, over here we will be creating the tree also. So first number will be our root. So let's give me number for the root.
17.
17. 70. Enter. Up now it will asking me enter data for the left of 70. So let's say कि 70 is our root node. ठीक है. Now first we will traversing into left mode. So pre-order insertion is happening, means root left right. So enter data. So we will be entering like, okay, we will enter 50. So 50 will be the left of 70. Then enter the more left of 50. So like we will say कि okay, 40 will be on the left. So 40 will be on the left. Now I'll say कि okay, enter the data of more left of 40. So I'll say कि no, I don't want any child for 40. So I'll say कि okay, -1 left of 40 is -1 means null is stored. Enter data for the right of 40. -1, I don't need child over there also. Now it will, after entering, saying no to 40 left and 40 right, after that it will store for 50 right. So whenever we enter, now enter data for right of 50. So in right of 50 I'll said ki okay, let's store 55 over there. So 55 is in the right of 50. Now if I'll say ki okay, I don't need a child for the 55, -1 and -1. For left is -1 and right is -1. Enter data for right of 70. So 70 is the main root where now we are entering in the right side. So we'll say ki okay, let's enter 200. So 200 will be entered over here. So now it will again asking the data for the left of 200. So left of 200 will be, let's say, 80. 80 is there now. Uh, right, and let's say I don't want child for the 80. Now enter the right of 200. Now I'll say ki okay, enter 800. So 800 is entered. Now it is asking for left of 800. I said ki okay, 400. Now I'll say ki okay, now 800 is here and 800 left is 400 over here. I said ki okay, now I am done. So I don't want child for 400, any child. Now I don't want any right child for 800, -1, and we are done. Now we have printed pre-order, in order and post order traversal over here. Let's calculate ourselves ki okay, is it right or wrong, how it's working. So let's look at first again. I pre-order, in order, post order, right? And what was the logic behind pre-order? Can someone tell me? Root,
First, we will print the root node and the left again right.
right. So root left right, in order is left root right, and post order is left right root. So this traversal is again only root is changing. Pre means root is prior to everyone. In order means root is in between left and right, and post order means root is in the end after left and right. So in pre-order, if we will look at it, root left right. So first we will print 70, then left side there is 50. Now 50 itself is a root of left subtree, 50, then 40, then 55. Then if we will come over here, there is 200, then root left, then right 800 and 400. So this is our pre-order. If we look at it, is it right or wrong? So 70, so 70, 50, 40, 55, 200, 80, 800, 400. So we are right. Now can somebody tell me in order, what will be the sequence for in order?
First, we will print 40.
So let's we print 40,
Again 50,
50,
55,
55,
70,
70,
80,
80,
200,
200,
400,
400,
800.
800. So let's check it out. So 40, 50, 55, 70, 80, 200, 400, 800. Someone else want to try post order sequence? Prashant, Jayashree, Raja, wanna try this post order?
Sir.
What will be the post order for this?
55, sorry, 40,
40,
55,
55,
50,
50,
70,
70. No,
80.
70 will not come, not come.
That
70
is
is the
root,
top
no?
node root. Left, right root. So left, right root. Left subtree is complete. then right subtree will be completed. After right subtree, 70 will come. 70 will be the last node
400.
into post order.
400, sir.
No, 80.
So when the recursive call will be occur, we will firstly we go to the paste left node, na?
Yeah, so initially you was right 40, 55, 50. The left subtree is completed. When you go to the right, the left will be 80.
Sir, we will go first to full the paste node, na?
Deepest left node.
Okay.
I'll tell you okay how. Left right root. So in this subtree, this is left, deepest left right.
Okay.
After that, we will go to this right. Then 50. When we will come to the right, so first left deepest is 80. Now in this subtree, right is this. When we'll go to the right, then we will print this 400. 80, I think 400, then 800, left right root, then 200, then 70. This is what I think. Let's check it with the system only. So 40, 55, 50, 80, 400, 800, 270, right?
Yes, sir.
So just don't get confused ki deepest or anything else. Just focus on that only, left right root. So when we started, we went to the left. We have printed the left. Now we will go to the right. So 55 is the right. After completing 40 and 50 left and right of this root node, we will print this root node. So left, right, root, right? Then we will go to the right subtree. In right subtree, 200, then 200 has a left and right. So let's print 80 first. Then we will go to the right side of over here. Over here already there is a left. So we will go to the left of this 400. Then 400 don't have any right brother. So we will print their root. Right. Now 280 left subtree is completed, right subtree is completed. Now we will print 200. Right. And after that this left subtree is completed, this right subtree is completed. Then we will print the total root, the 70. Is it clear everyone? How we created this program, or is there any confusion anyone? You can ask me questions. It will be great for us also. Prashant, Jayashree,
Yes. Nothing.
is it clear or is there any questions?
Yes. It's clear.
Okay, great. Yeah. Uh, so I'll share this program in our group also, right? So okay, in order also. Okay, I'll explain. Let's go. So let's first I try to create that over here also. So let's say this is 70, right? And in 70 is left what we did 50, and on 50 left we created 40 and 55 to this right. Then we will go over here like 200, then 80, then 800, then 400, right? So again it is don't read this one is little bit wrong. So what is in order? In order means left, root, and then right. Okay. So first we will go to the left, then root and right. Now if we will start this, this is the basic main root over here. So first we will go to the left. We will go to the left subtree. Now it is root for this root we will go to the more left, so they have the left. So first we will say 40 left, then root. So root of 40 is 50, then right, the right of this root is 55. Then the left part is completed, right, this part is completed. Now we will go to their root, because left is completed, their root is 70. Then we will go to the right subtree, right. Now this become the new root for this subtree. So first we will go to their left, so 80 is their left. Now 80 is completed, this left subtree is completed over here. So 200 become the root, so we will print 200. Then it will go to the right, so now it will go to the this subtree, right. So when this becomes a root, we will print their left is 400. So when 400 is completed, there is only one root left, that is 800, means 800 will come. So again, if we look at the in order, I hope we have done the right thing. So 40, 50, 55, 70, 80, 200, 400, 800, right. So our this traversal is very simple. What we did over here, we said ki, okay, we in order traversal we will go left, root, right. So what is the left? This is the root over here, this is the left subtree. In this left subtree it is the root. So in it is the root, then it is the left, then it is the root, and it is the right. So left, root, right, right. Then this subtree is completed. So this is the root for them, the 70 is the root for them. Now we will go to the right. When we will go to the right, this become the root, then this become the left part of that root. So left, root, then right part. But when we'll go to the right part, this become the root. The left of root is 400, so 400 will come first, then left, then root, then there is a no right, and it is completed. So is it clear? Can someone confirm? Okay.
Yes,
Okay.
sir.
So I'll share the program. So Saturday, Sunday will be off. So we will on Monday we will be continuing the binary search tree. So binary. So in binary search tree, the value of left node must be smaller than the parent, and the value of right node must be greater than the parent node. This rule is applied recursively to the left and right subtree of the root. So what is a binary subtree? It is a type of a binary tree who has a policy of having two child only, left and right, but they are having one more rule. The rule is simple. The left subtree or left node, left child should be smaller than the parent node or the root node, and right subtree or right child should be bigger than the root node. This is the basic logic. Like 40, if root node is 40, if 30 is there, 50 is there. So 30 is smaller than 40 and 50 is bigger than 40. Same way, if we look at the 25, 25 is smaller than 40, smaller than 30. That is why he is on the left node of 30. Same 35. So 35 is smaller than 40 but bigger than 30. So it is on the right side. Same way 45 is here. Same way 60 is here. Right. So that is how a binary search tree is formed. Advantages of binary search tree. So searching an element is easy, right? Because if I am trying to search 45, I know it is on the right side. Why? Because root node is 40. So if 45 is available, it should be on the right side of the node, not on the left side of that. As compared to array, linked list, insertion, deletion operations are faster in binary search tree. So it is much faster than normal array and linked list. So let's try to insert or create one tree, binary search tree. Like let's insert 45. So whatever first node we want to insert becomes the root node, right? So after root node, it will be decided कि okay, number will go on left or right. So now our root node is 45. So in step 2, whenever we will try to insert 15, so 15 is smaller than 45, so insert it as a root node of the left subtree. So 45, 15 went to the left side of 45. Why? Because 45 is less than the root node. Same as 79, insert 79. So 79 is greater than 45, so insert it as the root node of the right subtree. So it should go on the right side of the this root node. So 79 came over here. So 15, 45, 79. This is the structure right now. Now I'll try to insert 90. So 90 is bigger than 45, 79, so it should go on the rightmost node. Right, so 90 is here now. Insert 10. So 10 is smaller than 45, it should go on the left. Now it will check with the 15, it is smaller or bigger, it is smaller than 15, so it should go on the left of 15 also. So that's how it should go. Now the third stage, step 6, we'll try to insert one more number, 55 over here. So 55 is larger than 45, so it should go on the right side. Then it will check with the 79. So 55 is smaller than 79, so it should go on the left side of the 79. Now try to insert 12. So 12 is smaller than 45, and 12 is smaller than 45, so it is smaller than 45, go on the left subtree. It is smaller than 15, go on the left subtree. Now compare with the 10, it is bigger than 10, so it should go on the right side of the 10. Let's insert 20 in this binary search tree. So it is smaller than 45, so it should go on the left. Now it is bigger than 15, so it should go on the right side of the 15. Let's insert 50 now. So 50 is bigger than 45, let's go on the right side. It is smaller than 79, so it should go on the left side. Now it will check with the 55, it is smaller than 55, so it should go on the left side of the this node also. So that's our binary search tree, right? BST. So that's how we insert into binary search tree, right? So Ashish, is this clear? The this logic is clear ki how we go to left part or right part?
Yes, sir.
Okay. Rashmi, is it clear to you also? I think you are a new student. Okay. So you can, type your questions into chat box also. If you are, not able to talk, or if there are some issue while internet or any other. Now, searching in, today we are going to discuss only logics and how to create a basic program. The whole program we will create it tomorrow. Why? Because it will take 15-20 minutes to create one. Searching in binary search tree. So searching means to find and locate a specific element or node in a data structure. In binary search tree, searching node is easy because element in BST are stored into a specific order, right? So in binary search tree, it is easier to search. Like if you want to search 20 in this binary search tree, so first I'll check with the root node, right? So the key should be equal to root dot data. If it is there, right, is equal to key, it means I found the number. Second, if key is smaller than root node, so it should search on to the left subtree. So like I am searching 20, so 20 is smaller than 45, so we should go on the left part. Now it will check with the 15, it is bigger than 15, so it should go on the right side. Now it will check with this 20 root dot data is equal to key. Yes, we found it, and this is the location. So that is how it is going to find the location of 20. So first insertion, second searching, third deletion. How to delete numbers and from the binary search tree. in deletion in binary search tree involves three basic checking. First condition is again first condition is the node to be deleted is a leaf node, means whatever we are trying to delete is in the leaf node. Second, it is not a leaf node, it has one child. Third condition, it has two child. So these are the three conditions that we can found. So if when the node is deleted is the leaf node, it is easy. On the right of this 79, we will say कि it is null now and this number is deleted. Right? So deleting a leaf node is easy. Why? Because we have to just remove the reference of that. So it is simplest to delete. It is simplest case to delete a node in BST. Here we have to replace the leaf node with the null and simply free the allocated space. And done we are. Now the second condition will come. When the node to be deleted has only one child. In this case, we have to replace the target node with its child and then delete the child node. Right? So it is saying कि if they are having child, one child only, they have to replace it. So if you look at this subtree, sorry, this tree, and we want to delete 79, right? So we want to delete 79. 79 has one child, right, on the left subtree. Now replace it. So 55 came to this position and 79 is removed, right? So it created the balance also. 55 is bigger than the 45, right? And that's how it has been done. Third scenario, right, when the node deleted has two child or two children, sorry. So first find the in order successor of the node to be deleted. There is three steps to follow over here. First find the in order successor. So in order successor means that is immediately bigger than that number. After that, replace the node with the in order successor until the target node is placed. At last, replace the node with the null. So what, this is the one tricky one, right? So if we want to delete 45, right, which will be the new root node and who will take the place? Now first step, find a in order successor, right? In order successor of this is 55. How? Left root right. The moment will come to the right, the first left of the right subtree means 55 is the just bigger than 45 and smaller than 79, and replace them. So now 55 become the new root node and 40 we will free the space from the 45 now. So that is how we will delete a node into binary search tree. This is basic insertion. So let's this is the basic idea. I hope is it clear, Ashish?
Yes, sir.
Okay. So now let's roll into the basic idea of this program. So no, this is the program that we have created and we have executed also. Let's execute it one more time to understand what we are trying to do over here. Now this is binary search tree and there are 3 4 functions that we are trying to create over here. One is insertion, one is delete, one is searching. So if we are inserting numbers like 50, 30, 20, 40, 70, right? So how the tree will look like? मूवी नहीं हो रहा, ठीक है. सो इफ 50 आता है, So if 50 comes, 50 is our root node, right? So Ashish, 50 came over here.
Yes, sir.
Now 30 will go where? We inserted second number is 30.
Left,
Okay, so
left side.
30 came over here,
Parent node, left
right?
side.
Now 20,
20, sir, subtree of 30, left side.
right? 40,
Mm, 40, sir, 30 parent node and right side 40.
perfect. 70,
70, sir, 50, 50 right side. 50 roots and
right
right
side of
side
40.
70.
60,
60, 70 right, 70 left side.
right? So 70 is the
7
parent,
left side of
60 of left,
70.
right? 80 is the right side of 70,
Right
right? So if this is the
of
subtree,
70.
what will be the in order traversal? So what is in order traversal?
In order, sir, mm, root left right.
No, in order is left, root, right.
Left root. Yeah. Sorry, sir.
So yeah, how we define in order pre-order traversal, it is depend on the root. If root is coming in between left and right, it is in order. So what will be the
Mhm.
in order traversal for this?
Uh, 20, first 20 and 30.
30,
Uh, After that 40.
40.
Mm,
After 40, Ashish, after 40, am I audible? Okay, so after 40 it is 50, after 50 it is 60, then it is 70, then it is 80. So that's how we traverse the in order traversal. uh, I think it is okay, you are there, then it is okay. So now if we look at this the program, how we inserted it, if we are seeing it, so our traversal is perfect. So if you look at the in order traversal when we entered these number, so it is the same. So how it is the same? 20, 30. So first time 20, 30, 40, 50, 60, 70, 80. This is how we do the in order traversal. So in this program we are doing the in order traversal, right, and the insertion. So now I'll tell you a basic a logic. So we will develop the whole program tomorrow on the basis of that only. So we have to remember only two things. Uh, one, to check, if key is greater than root dot data, means we have to focus on right side or right subtree, right? And if key is smaller than root data, so we should focus on left subtree or left part of subtree. So these are the two basic logic that we are going to implement in everywhere, right? So it should be used into insertion part, it will be used into the deletion part, and it will be used into the searching part. So these two logics are the basic two logics that we are going to use into binary search tree, insertion, deletion, traversal. So yeah, we will make this program tomorrow. I'll share it today, so you can also read it out. If there are any issue, we will discuss it tomorrow morning. So hi everyone. Today we are going to discuss AVL trees. AVL trees invented by GM Edelson, Valeski and EM Landis in 1962. The tree is named after AVL in honor of its inventors, right? So AVL tree is a self-balanced tree that follows binary search tree properties, right? And created by these gentlemen. So AVL tree can be defined as height balanced binary search tree in which each node is associated with a balanced factor which is calculated by subtracting the height of its right subtree from the left subtree. So if for each node we will calculate the balance factor. So balance factor will be calculated through left of height and right of height will subtract. If the left or right, when we subtract this from the left, the answer should be come between from minus 1, 0 or 1. Other than this will be balanced, right? So balancing happen in a logic, right? So balance factor of any node is 1. It means the left subtree is one level higher than the right subtree. If balance factor is 0, it means left subtree or right subtree is equal height. If it is minus 1, then it means right subtree is having the more height than the left subtree. So as AVL tree, in this AVL tree we will calculate the balancing factor of each node, right? So let's start with the bottom. 65, no child, it means it is 0. So 25, 65, 85, 125 and 175, they all have the 0 balancing factor. Now if we look into it, for the 75, so 75 left is 1, right is 1, 1 minus 1 is 0, right? And let's look at 50 now. 50 has 1 height in left subtree and 2 height in right subtree. So 1 minus 2 is minus 1. uh, if we'll go same for 150, left is 1, right is 1, 1 minus 1 is 0, right? And if we look for the 100, 1, 2, 3, 3 height for the left, 2 height for the right, 3 minus 2 is equal to 1. So that's how we look at the subtree. Each node has the balancing factor from minus 1 to 1. Minus 1, 0 and 1. No one should reach to other than these numbers, means 2 or minus 2. If they reach to this level, means we need to rotate this tree to balance out their left or right subtree. So what kind of operation we perform? We'll perform insertion, we will perform deletion, and the AVL's tree will always perform this as a binary search tree, and they'll follow the basic rule of binary search tree. So what is a binary search tree? So binary search tree is like, if we are entering a number, right? So 10, 15, 5. So this is binary search tree. If we look at over there, why it is a binary search tree means left subtree should be smaller than the root and the right subtree is bigger than the root, right? This is the basic logic of binary search tree, and there should be only two child to each node. Now rotations, right? So whenever we will look at the AVL tree, whenever they are going outside the balance, means if they reach anywhere other than minus 1 to 1, then it means we need to balance them out, right? So that they will be again the AVL tree. If they are not balancing themselves, it means it's not an AVL tree, right? So there are four type of rotation: LL rotation, RR rotation, LR rotation and RL rotation. So LL rotation is, if you look at their name, LL means left subtree, RR means right subtree, LR means left subtree, right subtree and left subtree. Let's start with the RR. So RR and LL is the easy rotations where we look at them. When BST become unbalanced due to a node inserted into right subtree of the right subtree, then we have to perform RR rotation, means anti-clockwise rotation we have to do, right? So like we tried to insert A initially, it is okay, then we inserted B, it is okay. The moment we inserted C, A's balance is gone off the road, right? So it becomes 2, and the highest is allowed in a AVL tree is -1, 0 or 1. 2 is not allowed, means we need to rotate it. So now it is inserted into right subtree of the right subtree, means we have to rotate them on an anti-clockwise, means we will pull it from here and rotate it like this. It means B will become the new root and A become the left subtree and C become the right subtree. And now if we look at over there, they all are having the zero, what to say, balancing factor, and left subtree is smaller than root, right subtree is bigger than root, means they are following the rule of binary search tree, and because their balancing is below 2, means they are following the rule for the AVL tree also. Now LL rotation. So if we inserted a node, because of that, balancing is gone off the road, that is on the left subtree of the left subtree, means A is inserted over there and C's balancing factor becomes 2. Now because it is this, we have to do clockwise rotation, and that is our LL rotation, right? And it is kind of right rotation. Now we'll try to do the same thing. This will come, means B will be the root, A will be the left subtree and C will be the right subtree, and all balancing factor is 0. Now these two are the easy one, right? Why they are the easy one? Because we are doing the one time rotation over there. Now if we look at the LR rotation, so LR rotation is means a node is inserted onto the left subtree of the right. So first we will go to the left subtree, then we inserted on the right subtree of the that left subtree. So means we can't do it a single rotation. If we try to do the single rotation of right or maybe clockwise rotation, then what will happen? A will become the root node, C become the right node, and B become the left node. And this is wrong. Why? Because it is not following the property of a binary search tree. Why? Because A is the root, B is bigger than A. It can't be on the left side. So B should be gone the right side, right? So for that purpose, we will do the LR rotation. LR rotation means first we will do the what to say anti-clockwise rotation to the subtree. So now if we will do the same, so what will happen? C become this, will come on the left part, and A become the subtree of the B, left subtree of the B. Now it will look like LL rotation. Now we will do the clockwise rotation to this. So after becoming this, means A, B, C, we will do the clockwise rotation, then B become the parent, and A become the left side and C become the right subtree. If we'll do the same thing on the RL rotation will look like this, means first we'll go to the right subtree and right subtrees, then we'll go to the left subtree. Now again we can't do the same easy rotation like anti-clockwise rotation. If we'll try to do it, what will happen? Again C will come in the root, A will come on the left and B will come on the right. This is not following the binary search tree. B should be on the left of the C. So first what we will do, we will do the right rotation for the C. Then what will happen? A will come over here, B will come over here, and C will come over here. So when they'll become this, then we will do the anti-clockwise rotation. So after doing the clockwise rotation, what we will do? We will do the anti-clockwise. This become, then B become the root. After we will try to do the anti-clockwise rotation. A become the left subtree and C become the right subtree. Now the balancing factor is 0 for everyone, and they are following the binary search tree rule also. Means left subtree should be smaller than the root and right subtree should be bigger than the root. So now try to do this, make a program in Java or maybe any languages. try to enter these number. So if you will try to do this, I'll take you a little bit faster. So if we'll first try to insert this, H I J, the moment it becomes minus, they'll try to do the RR rotation, means anti-clockwise rotation, and this become the I H and J, means I become the new root, right? So that's how it will balance itself. Same thing will try to enter B and A. The moment B and A got entered over there, means they need to do the right rotation. So they'll do this, and B become the root over of the left subtree, and A become the left subtree of the B, and H become the right subtree. If we'll try to do this, the clockwise rotation over there, and IJ is there at the same place. Now if we look at over there, 1 0 0 0 0 means it's a balanced tree. So now you all can go ahead and do the programming. We'll try to do the programming tomorrow. If you have any query or any other issue, you can comment it down.